Okay, so good morning, everyone. We'll be starting with the today's session, that is continuation of solutions chapter. So starting with we shall brush up what was done yesterday. So first of all, you studied what is solutions. That is one second. So we have been discussing about what is a solution, that is a homogeneous mixture of two or more components. So you have taken an example of salt and water, and salt is said to be solute, you understood. Then water is said to be solvent, we understood. Then we also moved on to types of solutions, wherein, we decide the state of a particular solution by looking at the solvent that is present. Solvent andre, the one that is present in larger quantity. So larger quantity only, you have something called gaseous solution. Then you have liquid solution, Mathundu, solid solution. So these were the types of solutions, and we have also discussed the examples based on this. There was gold, that is 22 parts of gold with the 2 parts of copper. You remember it was a solid solution. So various types of solutions also we have discussed. Then we went to the term called solubility. The amount of substance that can be dissolved in particular amount of solvent was called solubility, we have seen. Then we went to expressing concentration. Concentration in the sense, the amount of solute that can be dissolved in a particular amount of solvent. That was called concentration. So H2, how much is the capacity of a solvent in order to dissolve the solute, or how much you can dissolve is called concentration, we said. Then under that you studied something called mass percentage. Mass percentage always, masses will be given in terms of grams. If you find solute and solvent in terms of grams, then you call it mass percentage. Then you went to mass by volume. Mass of the solute will be in terms of grams, whereas volume of solution will be in terms of ml. And then you went to volume percentage, wherein both solute and the solvent will be present in ml itself. This quantity that we take, or the unit that we take, will be ml itself. Okay, both are taken as liquid solutions only. But that is where we use that is volume percentage. Then we went to something called mole fraction. Mole fraction is nothing but XA. If you remember the formula, XA is equal to NA divided by Na plus NB. Na divided by Na plus NB. Yes. So after that, you went to one second. So XA is equal to Na divided by Na plus NB. This was the formula, where N stands for number of moles and Na plus NB stands for total number of moles of a particular component. Then you went to something called parts per million. I told you that this is mainly applicable in order to find out any particular concentration in trace quantity. And smaller quantity, only find out malikidre out of a million components. Then you use this term called parts per million. The formula goes as number of parts of solute divided by total number of parts of all the components into 10 to the power 6. As it is million, it is 10 to the power 6. That one thing you have to remember. Then you went to something called molarity, which is important. Molarity is number of moles of solute divided by volume of solution in liter, you studied. Then molality is number of moles of solute only, but divided by mass of solvent in kg. Here it is volume of solution in liter. Here it is mass of solvent in kg. Okay. And one more thing is, sometimes they ask this question, effect of temperature. How does it vary for molarity and molality? Molarity, when you say, it is dependent on temperature. So you see here, it is changes with the change in temperature. Why? Because molarity is nothing but number of moles of solute, right? Number of moles of solute divided by volume of solution in liter. Here, if you see, as you increase the temperature, suppose you are increasing the temperature, what happens to volume? Volume also keeps on increasing, correct? So who is temperature dependent is molarity is temperature dependent because as you increase the temperature, volume also keeps changing. But molality andre eno, it is number of moles of solute only, divided by mass of solvent in kg. Mass of solvent in kg. Andre, when you increase the temperature, is the mass going to vary? Mass will remain constant itself, right? So that is why you say that molality is independent of temperature, whereas molarity is dependent on temperature. That's why it is given as no effect. Molality no effect. Molarity changes with respect to temperature. That one thing you have to remember. Okay. Next, you went to the types of solutions, which you have already discussed. Then we went to something called binary solution. Binary solution, andre, there will be how many components? 2 components will be present in binary solutions. Like, you have salt and water. Ali 2 components there. One is salt and the other one is called water. So we have mainly dealt with only binary solutions. So factors affecting solubility of a solid and liquid were the first one. Solid and liquid, andre, you talk about that salt and water only. That is also an example wherein you have to remember that the factor affecting the solubility of a solid in liquid will be nature of solute and solvent. And I told you that polar solvent will only dissolve in polar solutes will only dissolve in polar solvents. Non-polar solutes will only dissolve in non-polar solvents. Or I asked you to remember that like dissolves always like components only. Like, organic solutes will dissolve in organic solvents only. Inorganic solutes will dissolve in inorganic solvents only. Okay. So that is one nature of the solute and solvent you have to remember. And the other one was effect of temperature, which is very important, I told you. So there was the first one. If the dissolution process, dissolution andre, dissolving. The salt is dissolving in water. That is called dissolution process. But when you can't dissolve more amount of salt, you find a stage wherein no more salt can be dissolved in that particular solution, then you call it a saturated solution. Saturated solution andre, ಅಲ್ಲಿ ಯಾವ process ಆಗ್ತಿದೆ ಹೇಳಿದ್ದು crystallization process ಆಗ್ತಾ ಇದೆ ಅಂತ. Okay. So the first process wherein you can dissolve the salt is called dissolution, but there is a moment or there is a limit wherein no more salt can be dissolved. That is called crystallization. So these two are opposite words. Dissolution and crystallization are exactly opposite of each other. So we are talking about dissolution. ಈಗ dissolution ಅಥವಾ salt dissolve ಆಗುದು endothermic reaction ಆಗಿದ್ರೆ. Endothermic ಅಂದ್ರೆ where heat energy is said to be absorbed. More and more heat absorbed andre delta H will be positive ಅಂತ ಹೇಳಿದ್ರು. So when the heat is absorbing and, in a system, when the heat is actually absorbed and when you try to increase the temperature, what will happen? The solubility will increase because according to Le-Chatelier's principle, the reaction will move in forward direction. Andre more and more solute it can dissolve. Energy is getting absorbed. But in the case of dissolution being exothermic andre already heat energy is released. Andre delta H is negative. Even when you supply extra energy, already heat energy there. When you still increase the temperature, what happens there? It still becomes insoluble. Why? Because the reaction is going to move backward direction. According to Le-Chatelier's principle, in order to balance itself or in order to, make use of this particular heat, it's going to go in the backward direction. That is what happens when you talk about exothermic reaction. Okay. So for an endothermic reaction, solubility increases with the rise in temperature. For an exothermic reaction, solubility decreases with the increase in temperature. These 2 points you have to remember. That is one thing. Then you went to effect of pressure. Pressure has no effect on the solubility of solids in liquid, you understood? So that has no effect, pressure. So 3 points or 3 factors that affects the solubility of solid in liquid. One is nature of solute and solvent. Then one you went to effect of temperature. Then other one was effect of pressure. Pressure has no effect because they are incompressible. This is also yesterday discussed. Then you went to factors affecting solubility of a gas in liquid. This would be the second Roman number. This would be the first Roman number. Solubility of solid in liquid. Then you went to gas and liquid. This will be the second Roman number. So under gas and liquid, first of all, you need to remember that pressure has a lot of effect. Why? Because when you talk about gases, pressure has a significant, change with respect to gases. Why? Because solids, when you apply pressure, there is no change. Whereas gases, when you apply pressure, there is, compression taking place. So of course, pressure will have an effect on the solubility of gas and liquid. Okay. So that is one thing. Then you went to this effect of pressure is given by somebody named Henry, and the law was called Henry's law, wherein the partial pressure, I spoke about the Coca-Cola bottle yesterday. Suppose you have a Coke bottle, imagine here you have the sweet drink, that is sugar solution is there. and you want to pass carbon dioxide in order to make that, drink fizzy, imagine, then how do you supply this carbon dioxide inside the bottle? What you do is you just compress the gas, or you apply pressure to the gas in order to make it dissolve in the liquid. So the partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas present in the solution. ಎಷ್ಟೇ pressure ಇಲ್ಲಿ ಇರ್ತದ ಅಥವಾ partial pressure of the gas ಎಷ್ಟೇ ಇರ್ತದ, it is proportional to how much amount of gas is being dissolved in the solution. That is what it says. Okay. So the expression also we discussed, that is P is equal to KH into X, where P stands for partial pressure of the gas, X stands for mole fraction, and KH stands for Henry's constant. Henry's constant. And I told you that Henry's constant is friends with whom? Temperature. But whereas Henry's constant is enemy with whom? That is solubility. Then it is enemy with partial pressure. And then it is also inversely proportional to whom? Mole fraction. All these, it is inversely proportional. Kali temperature ke matra, it is directly proportional. So they may ask you, as the temperature increases, what happens to Henry's constant? Decreases. As Henry's constant increases, solubility decreases, partial pressure decreases, mole fraction also decreases. Everything ulta. Okay. So that is one thing regarding Henry's law. Then you went to the second type, that is solubility of liquid in liquid. Liquid in liquid. And this is given by Henry's law. The Raoult's law. Okay, I'm sorry for that. So gas in a liquid is given by Henry's law. Then liquid in liquid is given by Raoult's law. And liquid in liquid also, special condition was that these has to be the volatile liquids. We have learned volatile liquids. Volatile andre ಯಾವುದೇ ನಾವು ಲಿಕ್ವಿಡ್ ತಕೊಂಡ್ರು, imagine alcohol ತೆಗ್ದಿದ್ದೀವಿ ಅಥವಾ ಎಸಿಟೋನ್ ತೆಗ್ದಿದ್ದೀವಿ, they evaporate easily at the room temperature. Evaporate ಅಂದ್ರೆ from the liquid state they evaporate to its state, gaseous state. ಇಂಥ ಲಿಕ್ವಿಡ್ಸ್ ಗೆ ಹೇಳುದು ನಾವು volatile liquids ಅಂತ. ಸೊ ಇಂಥ ಒಂದು ಲಿಕ್ವಿಡ್ಸ್ ಗೆ ಅಪ್ಲೈ ಮಾಡುದು ನಾವು Raoult's law ಅಂತ. Before getting into Raoult's law, I asked you to remember what is vapor pressure. Okay, so you're talking about vapor pressure here, no more partial pressure of the gas. Raoult's law anta helidre, you should remember the word vapor pressure. What is vapor pressure again? So imagine you have alcohol and acetone. I asked you to remember this example yesterday. So here there was alcohol and acetone. You know that these are highly volatile. Volatile means they evaporate to gaseous state. So ivugalu, that is alcohol and acetone, vapors agide anta ansu. Okay, so and I told you these gaseous molecules, they don't stand like that. They of course collide with each other. They move randomly, because of which they collide with each other. Then idan hit ಮಾಡ್ತದೆ, ಇದನ್ hit ಮಾಡ್ತದೆ, like this. Okay, so they keep colliding with each other, because of which they exert pressure. Okay, ಇಲ್ಲಿ top of the liquid ಗೆ they exert certain pressure. ಆ pressure ಅನ್ನು ಹೇಳುದು ನಾವು vapor pressure ಅಂತ. Okay, so the pressure exerted by the vapors on the surface of the liquid, that is called vapor pressure. So Raoult's law vapor pressure ಅನ್ನು ಹೇಗೆ connect ಮಾಡಿ ಹೇಳ್ತದೆ. Okay, so it says that, please see here, this is a sentence, or here is a law. So it states that for a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to partial vapor pressure of each component. Andre acetone vapor pressure ಮತ್ತೆ alcohol vapor pressure will be directly proportional to mole fraction present in the solution. Andre how much amount of acetone is present in the solution, how much amount of one minute. Yes, how much amount of acetone is present in the solution, the same amount of gaseous particles will be present on the top of it, or vapor pressure will be also so much only. That is what
fingers and
I think somebody's speaker is on. Can you please mute it, sir? Okay. So here we were talking about vapor pressure. So we were talking about the mole fraction present in the solution. Eshte alcohol ನಾವು ಇಲ್ಲಿ ತೆಗೆದಿದ್ದೇವೋ ಅಷ್ಟೇ ವೇಪರ್ಸ್ ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದೆ. ಎಷ್ಟೇ ಎಸಿಟೋನ್ ನಾನು ಇಲ್ಲಿ ತೆಗೆದಿದ್ದೇನೋ in the beaker, same amount of vapors will be formed, is what Raoult's law says. Okay. So again, once again, you need to learn the statement as the law, is given. You need to exactly write it as it is. So for a solution of volatile liquids, the partial vapor pressure of each component in the solution is directly proportional to mole fraction of the solution. Okay. So I told you that we'll be using something called Dalton's law. Dalton's law says that P total, if you want to find total pressure, find out ಮಾಡ್ಲಿಕ್ಕಿದ್ರೆ, you have to add partial vapor pressure of alcohol plus partial vapor pressure of acetone. ಅದು 1 and 2 ಅಂತ ತೆಗೆದಿದ್ದೇನೆ. ಆಲ್ಕೋಹಾಲ್ ಮತ್ತೆ ಅಸಿಟೋನ್ ಪ್ರೆಷರ್ ಒಟ್ಟಿಗೆ ಬಂದ ಕಾರಣ we call it total pressure. ಈ total pressure ಅನ್ನು P1 plus P2 ಅಂತ ತೆಗೆದಿದ್ದೇನೆ. So this is according to Dalton's law, but Raoult's law apply ಮಾಡುದಾದ್ರೆ they said that it is directly proportional to the mole fraction of the solution. ಅಂದ್ರೆ pure component ಅಲ್ಲಿ ಎಷ್ಟು pressure ಇದೆಯೋ into the mole fraction of the first one, that is alcohol maybe, plus P2 naught ಅಂದ್ರೆ ಎಷ್ಟು vapor pressure ಇದೆಯೋ in the pure form, ಖಾಲಿ acetone ತೆಗೆದ್ರೆ ಎಷ್ಟು vapor pressure ಇದೆಯೋ ಅದ್ರದ್ದು mole fraction. Okay, so it is directly proportional to partial vapor pressure and mole fraction of the solution. So this is given as the expression for Raoult's law, that is P total is equal to P1 naught x1 plus P2 naught x2. This will be the expression for Raoult's law. Okay. If you want to see it in a better way, or in order to understand this, let's take a graph and check out how exactly you need to learn this. A moment, please. Yes. Hope the screen is visible. Yes. So talking about Raoult's law. So we just discussed that. It states that for a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to mole fraction. And then you found that P total according to Dalton's law, it is P1 naught x1 plus P2 naught x2 is the expression for Raoult's law and the kaltidvi. Now, when you talk about, P total, I also told you that x1 and x2 are mole fraction, right? So it is also known that x1 plus x2 is equal to 1. Andre mole fraction of both the components in a binary solution will be always equal to unity, that is equal to 1. Or if you want to find out in terms of x2 anta hakidre, this will be 1 minus x1, correct? When you rearrange. So this only, let me put it in this form. So P1 naught x1 plus P2 naught. Nange ella terms iga x1 prakara beku. So what do we do? You put it as 1 minus x1. So if you are multiplying it inside, so P1 naught x1 plus P2 naught minus P2 naught into x1. This will be the expression. Or if you still want to rearrange L x1 terms and ottige tandre, you have P1 naught minus P2 naught into x1 plus P2 naught will remain as it is. So this way also you can, express Raoult's law. If suppose in the numerical you only find only one mole fraction is given, then what you do, you put it in terms of one of the mole fraction. Hige sa bariಬಹುದು, athava you can go for the first form also. Anything which you feel is easy, you can use. Okay. But depending on the numericals, you have to alter the formula and write down. But this will be the main formula. P total is equal to P1 naught x1 plus P2 naught x2. This is about Raoult's law. Now I told you that P1 naught x1 and P2 naught, I asked you to remember what is naught also, right? Naught in the sense you're talking about pure form anta helideve, correct? You're talking about pure form. So how exactly can we represent this graphically? Okay, let's check that. So imagine here, I'll be focusing here. Please see this first diagram here, the first column. Okay. Yes. So if you talk about this, let us just, identify what exactly the plots we have to put it up. So in the y-axis, now idu y-axis, idu x-axis anta tegre. Okay. Here you have mole fraction and here you have vapor pressure. Imagine. Okay. So mole fraction anta helidre, XA, you of course are dealing with binary solution. Binary solution andre there is A also, there is component B also. Suppose I take mole fraction of A as 1 here. Andre mole fraction of A matra ide. It's in the pure form right now. A do matra ide. But XB will be taken as 0. Okay, let me just put it up here separately for you. So illi vapor pressure ide, illi mole fraction ide. So let me just take it as x1 is equal to 0 maybe. Idu x2 equal to 1 anta tegidane, just for my instance. And x1 has become 1 here, x2 will be equal to 0 anta tegidane. You know, what you understand from here is that when you go from left hand side to right hand side, Kali mole fraction of yaru illi ide, that is x2 only, but x1 is nothing. It is not even there. But ನೀವು right hand side ಗೆ ಬರುವಾಗ x1 mole fraction ಜಾಸ್ತಿ ಆಗಿದೆ, whereas x2 mole fraction ಇಲ್ವೇ ಇಲ್ಲ. Okay, so I'm going to plot both the sides, the vapor pressure. So in the y-axis, I'll be plotting vapor pressure. You know that when x1 is equal to 0, and in the right hand side, when x1 is equal to 1, only focus on x1 right now. So illi 0 ittu, papa, illinda varuvaga, it has become 1, imagine. So ಏನಾಗ್ತಿದ್ರೆ the vapor pressure? X1 component, andre kali alcohol tegididre, adra vapor pressure, what will happen? When you increase the concentration, as per Raoult's law, even vapor pressure also increases. So kali x1 idu vapor pressure increase adaga, nange of course yava line sigbeku, linear line sigbeku, atava straight line sigbeku, correct? Yes. So here if you see, this is only the plot of, yakandre left hand side and the right hand side ge baruvaga, x1 idu mole fraction increase agta untu anta. So mole fraction increase ada, automatically vapor pressure se increase agtade according to Raoult's law. So what will be its vapor pressure? I'll put it as P1. Why? Because this side, in the right hand side, I only have x1 ka mole fraction, correct? So let me just take it as P1 naught. Ido okay, left hand side and the right hand side, vapor pressure is increasing. Why? Because mole fraction of 1 is also increasing. Same way, the other side when you come, that is from x2. x2 is 0. Now only focus on x2. x2 0 is there. But when you go from right to left, what is happening to mole fraction of x2? It is increasing. So automatically what happens to its vapor pressure? Vapor pressure is increase after the immersion. Okay. So this is a plot that you got. Now what I want to do is, if I just want to find out, so if this is a plot of px2, right? So let me just take it as p2 naught. ಈಗ ಎರಡು ಕಾಂಪೊನೆಂಟ್ಸ್ ನಾವು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದೇವೆ. ಅಂದ್ರೆ we have p total. p total ಅಂದ್ರೆ p1 naught and p2 naught ಇದು plot, correct? So what you do is you will have a, p total finding. What you can do is you can just join the lines wherein you get the p total. So p total will be equal to p1 naught x1 plus p2 naught x2. This is how the Raoult's law is given. So the same type of graph is given here, just for your reference. Again, so P total will be found here in between, that is PA plus PB. Join these two lines, you get the partial pressure of A and B, that is total of partial pressure of A and B. Now, most of the solutions ge apply after that. Like, P total can be found from PA plus PB. Adu maadbodu. So such type of solutions wherein you get exact graph. Iga ನಾವು ತುಂಬಾ solutions ಅಲ್ಲಿ ಹೀಗೆ try ಮಾಡ್ತೀವಿ, and then we got the exact graph like this. This means that the solutions are going to obey Raoult's law. Okay? This means that the solution is going to obey Raoult's law anta ಹೇಳ್ತೇವೆ. ಹೀಗಿದ್ದೇ graph ಬಂದ್ರೆ ಎರಡು solution ಗೆ, then you call it is obeying Raoult's law. Obeying Raoult's law anta ಹೇಳಿದ್ರೆ, those solutions will be called something called ideal solutions. Very, very important. The solutions that obey Raoult's law, in the day graph bandre, wherein P1 naught x1 plus P2 naught x2 will give you the P total value, and exactly you get the graph something like this, which is coinciding each other, then you call it an ideal solution. Okay. But ide graph anno, suppose you slightly get it in this way. You see that it is a positive deviation from Raoult's law anta kodidare. Andre, ide graph iddadu, but slightly adra vapor pressure idu line nodi, ee line iddadu illi, idu original line iddadu. Okay. Slightly it has gone above, slightly increase agide adra vapor pressure. Then you call it what? Positive deviation. It has gone towards a positive scale. It has gone higher vapor pressure. Same way, if you check this right hand side, you have partial vapor pressure being decreased. You see the line has exactly come down. The pressure is less, which means you call it a negative deviation. ಯಾವುದು ಡಿಕ್ರೀಸ್ ಆಗಿದೆ, ಯಾವುದು ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಇದು ಈಕ್ವಲ್, ಇಲ್ಲಿ ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಇದು ಡಿಕ್ರೀಸ್ ಆಗಿದೆ. ಇದು ಅಂದ್ರೆ ಏನು? ಅಲ್ಲಿ ವೇಪರ್ ಪ್ರೆಷರ್ ಹ್ಯಾಸ್ increased or decreased or it remains the same. So mainly ನಮ್ಮ Raoult's law ಯಾವ್ದ್ರ ಬಗ್ಗೆ ಮಾತಾಡೋದು? It is all about vapor pressure with respect to mole fraction. Vapor pressure increase ಆಗಿದ್ರೆ you call it positive deviation. Vapor pressure decrease ಆಗಿದ್ರೆ you call it negative deviation. If you get exactly the same graph as it is, then you say it is obeying Raoult's law, which means it is what type of solution? Ideal solution ಅಂತ ಹೇಳ್ತೇವೆ. ಅದೇ increase ಮತ್ತೆ decrease ಆಗಿದ್ರೆ you call it a non-ideal solution ಅಂತ ಹೇಳ್ತೇವೆ. Hope it is clear. Hope it is clear. Obeys Raoult's law, ideal solution. Does not obey Raoult's law, it can be positive, it can be negative. Those are called non-ideal solutions. Okay, let's talk about only the ideal solutions part here. So I hope you understood this graph. If two solutions obey this graph and you get exactly this graph, then you call it an ideal solution. ಈಗ ideal solution ಅಂದ್ರೆ ಯಾವಾಗ ಇಂಥ ಗ್ರಾಫ್ ಸಿಗ್ತದೆ ಅಂತ ನಮ್ಗೆ you'll have to check. ಅದೆಂತ ಅಂತ ನೋಡ್ಬೇಕು. So imagine ನೀವು maybe I'll just give an example. Second, yes. Maybe you talk about benzene. Benzene structure ಈ ತರ ಇರುತ್ತೆ, correct? ಅದೇ ಇನ್ನೊಂದಿದೆ, that is toluene. Toluene is again benzene only, but here you have CH3 as a substituent group, correct? Now you see that base compound, adra original form ಏನು benzene, correct? So ಇಲ್ಲಿ ಖಾಲಿ benzene ಅನ್ನು ನೀವು, benzene is an organic liquid, so it is an organic liquid. Even toluene is in the liquid form. ಖಾಲಿ benzene ಒಂದು beaker ಇದೆ, okay, and ಖಾಲಿ toluene ಇದೊಂದು beaker ಇದೆ. Imagine now, ಇವರ ಬೇಸಿಕ್ ಫಾರ್ಮ್ ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್, ದೊಡ್ಡದೇನು ಡಿಫ್ರೆನ್ಸ್ ಇಲ್ಲ, ಖಾಲಿ ಒಂದು CH3 ಗ್ರೂಪ್ ಏನೋ ಎಕ್ಸ್ಟ್ರಾ ಇದೆ ಅಷ್ಟೇ. ಬಟ್ ವೆನ್ ಯು ಮಿಕ್ಸ್ ದೀಸ್ ಬೋತ್, ಈಗ ನಾವು ಇದನ್ನು ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ, ಬಿಕಾಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ರೌಲ್ಸ್ ಲಾ ಇಟ್ ಇಸ್ ಓನ್ಲಿ ಫಾರ್ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ 2 volatile liquids. ಇಟ್ಸ್ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ 2 volatile liquids. ಮಿಕ್ಸ್ಚರ್ ಅಂದ್ರೆ ಅಫ್ಕೋರ್ಸ್ ನಾವು ಇದನ್ನು ಮಿಕ್ಸ್ ಮಾಡಬೇಕು. ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಡು ಯು ಸಿ ಎನಿ ಚೇಂಜಸ್ ಹ್ಯಾಪನಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಮ್? ಬಿಕಾಸ್ ಬೆನ್ಸೀನೇ ಇದ್ದದ್ದು, ಇಲ್ಲೂ ಬೆನ್ಸೀನೇ, ದೊಡ್ಡದೇನು ಚೇಂಜ್ ಇಲ್ಲ, ಒಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಇದೆ. So when you try mixing them, there's no much difference you see when you add them. ಆಯ್ತಾ? ಅವುಗಳ ಇಂಟ್ರಾಕ್ಷನ್ ಅಥವಾ ಅವುಗಳ ಏನು ಫೋರ್ಸಸ್ ಇತ್ತ, this was called AA force ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ. ಬೆನ್ಸೀನ್ ಒಟ್ಟಿಗೆನೆ ಯಾವ ಫೋರ್ಸ್ ಇತ್ತು, ಇಲ್ಲಿ ಬಿ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ, ಇಲ್ಲಿ ಟಾಲ್ವೆನ್ ಒಟ್ಟಿಗೆ ಯಾವ ಫೋರ್ಸ್ ಇತ್ತೋ ಇಂಡಿವಿಜುವಲಿ, when you try mixing, it becomes A and B, right? A and B, any attraction is going to happen or any repulsion? ಇಲ್ಲ, ಅವ್ಗೆ ಹೇಗಿದ್ದದ್ದು ಹಾಗೇನೆ ಇದೆ, because they are almost parental form or the original form is same, benzene ಅಲ್ಲ. Understood? So ನೀವು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ್ಲೂ ಎರಡು ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ಅಥವಾ ಮಿಕ್ಸ್ ಮಾಡದಾಗ್ಲೂ in the original form, their attraction or their forces remain the same. ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಆ ಗ್ರಾಫ್ ಸಿಗ್ತದೆ. That's why you call it what type of solution? Ideal solution ಅಂತ, because there is no attraction happening, no repulsion happening. Whatever forces used to be there before, the same forces are being there right now also. ಅದಕ್ಕೆ ಹೇಳುದು ideal solution ಅಂತ. Hope it is clear. Hope it is clear. Like, you can take another example, something called, chloroethane. Chloroethane, how do you write? C2H5. Ethane ಅಂದ್ರೆ ಎರಡು ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. Chloroethane ಅಂತ ತಕೊಳ್ಳಿ. Maybe you take bromoethane. ಏನ್ ದೊಡ್ಡ ಡಿಫ್ರೆನ್ಸ್ ಇದೆ ನೋಡಿ. ಇದು ಸೇಮ್ ಕ್ಯಾಟಗರಿ, ಸೇಮ್ ಫ್ಯಾಮಿಲಿ. ದೇ ಆರ್ ಕಾಲ್ಡ್ ಹ್ಯಾಲೋಜನ್ಸ್. ಅವರ ಪ್ರಾಪರ್ಟೀಸ್ ಆಲ್ಮೋಸ್ಟ್ ಸಿಮಿಲರ್ ಇರ್ತದೆ. ಈಥೇನೆ ಪೇರೆಂಟ್ ಇಸ್ ಸೇಮ್ ಓನ್ಲಿ. Before adding them together, or after adding them together, the forces will remain the same only, because there is nothing different group is not there, no? So it remains the same. That's why you call it ideal solution. Okay, the graph you're going to get will be the same for both of the solutions. That is where you call it ideal solution. So that's why it is told here. See this point here, see this point. AB interactions are almost same as AA interaction or BB interaction. Okay, AA interaction or BB. This is almost same as. All right. So, and you also have to note it in terms of physical quantity also. Physical quantity ಬಗ್ಗೆ ಮಾತಾಡೋದಾದ್ರೆ, what is this delta H mix? When you mix it together, delta H ಅಂದ್ರೆ enthalpy. Enthalpy ಅಂದ್ರೆ heat change. ಯಾವುದೇ heat change ಆಗ್ತಿತ್ತೋ in the original form, after mixing also the heat change will remain the same. There won't be any difference. That is what it says. So heat change or energy change will not be there when you try mixing them together, or when they were in the pure form also. So that's why delta H mix equal to 0. What do you mean by delta V? It is volume. Of course, volumes ಹಾಗೇನೆ ಇರ್ತದೆ. ಅಂದ್ರೆ ನೀವು 10 ml of benzene ಮತ್ತೆ toluene ಹಾಕಿದ್ರೆ total quantity will be 20 ml. ಅಲ್ಲಿಂದ ನಿಮ್ಗೆ ಅಟ್ರಾಕ್ಷನ್ ಆಗಿ ಏನಾದ್ರು ಡಿಫ್ರೆನ್ಸ್ ಆಗಿದೆ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ, ಅಥವಾ ಕಮ್ಮಿ ಆಗಿದೆ, ಜಾಸ್ತಿ ಆಗಿದೆ, ನಥಿಂಗ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್. 20 ml ಇದ್ದದ್ದು ಹಾಗೇನೆ ಇರ್ತದೆ. 10 ಇದ್ದದ್ದು ಆಡ್ ಮಾಡಿದಾಗ 20 ml ಇರ್ತದೆ. ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಅಟ್ ಆಲ್. ದಟ್ಸ್ ವೈ ಯು ಸೇ ಡೆಲ್ಟಾ ವಿ ಮಿಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ. ಸೊ ಫ್ಯೂ ಎಕ್ಸಾಂಪಲ್ಸ್ ಆರ್ ಗಿವನ್. ದಟ್ ಇಸ್ ಡೈಲ್ಯೂಟ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಬೆನ್ಸೀನ್ ಪ್ಲಸ್ ಟಾಲ್ವಿನ್. ಈಗ ಹೇಳಿದ್ದೆ. You can also take an example of chloroethane, bromoethane. All these will be examples for ideal solutions. MCQ it can be asked. Avaru eradu, they'll give you options of 2 pairs of solutions. You will have to identify who is an ideal solution and who is non-ideal. Same family ಅಥವಾ same category groups idre avarannu you classify it as ideal solution. Okay. Next, you have something called non-ideal solution. Moving on to non-ideal solution. So this should be okay with you. What is ideal solution? Let me just club it up together for you. So ideal solution anta helidaga, with respect to non-ideal solution ಅಂತ ಹೇಳಿದಾಗ non-ideal solution ಅಲ್ಲಿ ಎರಡು ಟೈಪ್ ಇತ್ತು. ಒಂದು upper graph, that is positive deviation, ಇನ್ನೊಂದು ಕಮ್ಮಿ ಆದದ್ದು vapor pressure, that is called negative deviation. Let's talk about it in detail. I'll come to it, but before that you need to differentiate between ideal and non-ideal solutions. Okay, the first point is that AA interactions ಮತ್ತೆ BB interactions ಯಾವಾಗಳಿತ್ತು, that will be almost similar to which one? AB interaction. Whereas ಇಲ್ಲಿ non-ideal ಅಲ್ಲಿ ಏನೋ ಆಗಿತ್ತು, the vapor pressure increase ಆಯ್ತು, vapor pressure decrease ಆಯ್ತು. So there are some changes that you see. So how do you say it? AA interaction versus BB interaction was not equal to, it won't be similar to your AB interaction. Important point. Then you went to the delta H mix, andre enthalpy of mixing. When you mix them, heat energy change itta ilva? No, there was no heat energy change, because ideal solution alli avugalu hege itta before, after also they'll remain the same. Even in the case of the ideal solution, volume mixing, is there any change? No change. So delta V mix also will be equal to 0. Then you can give an example of anything, that is benzene and toluene nimge nenpidudadre, you can go for that as an example. Okay, so this will be an example. In the case of the second point here, that is ideal solution and non-ideal solution, you say that delta H mix is not equal to 0. That should be okay. Then volume mixing will not be equal to 0. Some changes will be there. That's why you found vapor pressure jaasti agittu, kammi agittu. So you will find a volume change. I'll talk about it. And then maybe you can take an example. Before discussing the example, let's get into what is non-ideal solution. Then I'll come to it. Okay. So, okay, getting back to what is that non-ideal solution. Very, very important again. 3 marks question in the boards and all. They ask this, what is the difference between non-ideal solution showing positive deviation and negative deviation? Positive andre vapor pressure jaasti irutte. Negative deviation andre vapor pressure kammi irutte. You can exactly detect by using the graph. It should be easy for you. Anyway, so talking about non-ideal solution showing positive deviation. Positive deviation andre I told you vapor pressure jaasti agide. Idu original line. Okay, illinda onchuru jaasti agide. You see, vapor pressure has increased. Andre enu, there can be two types of interactions. Just you need to get it. You need to understand. So you understood that non-ideal solution can be positive deviation, innondu negative deviation. Correct? Ega, two types of interactions are possible. So idu positive matte negative, vapor pressure increase aaytu decrease aaytu, idu yaudra basis alli heludu ನಾವು interaction basis alli heludu. Interaction andre ಖಾಲಿ AA ಇತ್ತು, imagine ಇದು ಒಂದು ಬೀಕರ್ ಅಲ್ಲಿ ಇತ್ತು, ಖಾಲಿ BB ಇತ್ತು ಇನ್ನೊಂದು ಬೀಕರ್ ಅಲ್ಲಿ, ಆಯ್ತಾ? Two types of interactions are possible. One is there can be attraction between A and B, mix ಮಾಡಿದಾಗ attract ಆಗಬಹುದು, ಅಥವಾ there can be repulsion between A and B. Okay, so two types of interaction for positive deviation and negative. Which one I'll tell you, but for now you should know that two types of interaction are possible. One is attraction and the other one is repulsion. ಈಗ positive deviation ಅಂದ್ರೆ ನಿಮ್ಮ vapor pressure increase ಆಗಿದೆ. Let's understand that. So A B ಅನ್ನು mix ಮಾಡಿದ್ದೇವೆ. Okay, of course we are talking about solution of two volatile liquids. Mix ಮಾಡಿದಾಗ ಇವುಗಳ ವೇಪರ್ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಬೇಕಿದ್ರೆ, ಅಂದ್ರೆ ವೇಪರ್ ಎಸ್ಕೇಪ್ ಆಗ್ಬೇಕಲ್ಲ, ಆಗ ಮಾತ್ರ ಅಲ್ಲ ವೇಪರ್ ಪ್ರೆಷರ್ ಬರೋದು. ಸೊ ಈ ಎ ಬಿ ವೇಪರ್ಸ್ ಎಸ್ಕೇಪ್ ಆಗಿದೆ ಅಂದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗಿದೆ, ತುಂಬಾ ವೇಪರ್ಸ್ ಇದೆ. ಹಾಗಾದ್ರೆ ಅವುಗಳ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ಬೇಕಾ? ಎ ಬಿ ಬಿಟ್ವೀನ್ ಅಲ್ಲಿ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ಬೇಕಾ ಕಮ್ಮಿ ಇರ್ಬೇಕಾ? ಅವುಗಳು ಈಸಿಲಿ ವೇಪರ್ ಆಗ್ಬೇಕಿದ್ರೆ ಅವುಗಳ ಅಟ್ರಾಕ್ಷನ್ ಕಮ್ಮಿ ಇರ್ಬೇಕಲ್ಲ, ಕಮ್ಮಿ ಇದ್ರೆ ಮಾತ್ರ ಅವ್ರು ಬೇಗ ಹೋಗಿ ವೇಪರ್ಸ್ ಆಗೋದು. ಅದೇ ಜಾಸ್ತಿ ಇದ್ರೆ what will happen? The force will be too tight in order for them to escape into vapors. So force will be very less. That's why they escape into vapors easily. So what do you say that here it is undergoing attraction or repulsion? It is undergoing repulsion. ಯಾವಾಗ ಅವರ forces before was stronger, but after mixing it has become weak. After mixing it has become weak. That's why they are escaping into vapors. Vapors escape adre automatically their vapor pressure increases. That's where they show which deviation? Positive deviation anta heludu. So what has happened in the case of positive deviation? It is repulsion. But in the case of attraction will be negative deviation. Hege heludu? Before whatever mixing, that is AA ಮತ್ತೆ ಇದು BB, of course ಅಲ್ಲಿ forces ಇರುತ್ತೆ, but mix ಮಾಡಿದಾಗ there will be A and B. ಇಲ್ಲಿ ಸಪೋಸ್ ಸ್ಟ್ರಾಂಗ್ ಅಟ್ರಾಕ್ಷನ್ ಇದ್ರೆ, ಎ ಮತ್ತೆ ಬಿ ಯ ನಡುವಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಅಟ್ರಾಕ್ಷನ್ ಇದ್ರೆ Can they escape to vapors easily? Illa. Correct? So what happens to vapor pressure? Decreases. Illi vapors ಬರ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ ಯಾಕಂದ್ರೆ A and B strong forces ಇದೆ. ಕಮ್ಮಿ vapors ಇದೆ. ನೋಡಿ ಇಲ್ಲಿ ಜಾಸ್ತಿ vapors ಇಲ್ಲ. ಇಲ್ಲಿ ಕಮ್ಮಿ vapors ಇದೆ. So what do you say? Vapor pressure has decreased. Decrease ಅಂದ್ರೆ ಯಾವ deviation? Negative deviation ಅಂತ ಹೇಳಿ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಅಟ್ರಾಕ್ಷನ್ ಆಗುದಿದ್ರೆ ಇಟ್ ಇಸ್ ಅ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್, ರಿಪಲ್ಷನ್ ಆಗುದಿದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂತ. ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ಅಟ್ರಾಕ್ಷನ್ ಇಲ್ಲ, ರಿಪಲ್ಷನ್ ಇಲ್ಲ, ಆಸ್ ಇಟ್ ಇಸ್ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಆಸ್ ಇಟ್ ಇಸ್ ದೆಲ್ ರಿಮೂವ್. ಯಾವುದೇ ಫೋರ್ಸಸ್ ಇತ್ತು ಅದೇ ಫೋರ್ಸಸ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಆಫ್ಟರ್ ಮಿಕ್ಸಿಂಗ್. ಹಿಯರ್ there can be attraction. Attraction idre negative deviation, vapors baralla, that's why negative deviation. Repulsion idre aram se there will be escape of vapors, that's why you call it positive deviation. Athwa you talk about delta H of mixing. Delta H of mixing. Ideal solution ge eshtiddadu value 0, almost 0. But when you talk about positive deviation ge, delta H mix will be equal to positive value. Positive value andre it is greater than 0 or less than 0, it will be greater than 0 anta artha. Okay, but whereas in the case of negative deviation, delta H mix will be less than 0. Less than 0 andre alli attraction will be there. So it is less than 0, or you can call it as negative. Simple to remember. Positive deviation andre delta H mix will be positive. Negative deviation andre delta H mix will be negative. Hage so baribodu. Athwa delta V mix volume matadudadre, here it will be positive deviation, here it will be negative deviation with respect to volume. Okay. Now, you know, if I have to give you an example, ಇಲ್ಲಿ ನಾವು 10 ml of ಯಾವುದೇ ಒಂದು ಲಿಕ್ವಿಡ್ ಆಡ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಒಂದು 10 ml of ಲಿಕ್ವಿಡ್ ಇತ್ತು ಇಮ್ಯಾಜಿನ್. ಓಕೆ, ಇಲ್ಲಿ ರಿಪಲ್ಷನ್ ಆಗೋದು. ಸೊ ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಮಿಕ್ಸ್ will be not equal to 20 ml. Why? Because 20 ml ಬಂದ್ರೆ it is what type of solution? Ideal solution, equal ಇದ್ರೆ. ಬಟ್ ಇಲ್ಲಿ ರಿಪೆಲ್ ಆಗುದಲ್ಲ, ರಿಪೆಲ್ ಆದ ಕಾರಣ ಅವರ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ವೇಪರ್ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆದ ಕಾರಣ ಆಟೋಮ್ಯಾಟಿಕಲಿ ದ ವಾಲ್ಯೂಮ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. ದಟ್ಸ್ ವೈ ಇಟ್ಸ್ ಪಾಸಿಟಿವ್. ಮೇ ಬಿ ಯು ಗೆಟ್ ಇಟ್ ಆಸ್ 20.1 ml ಬರ್ಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಉಂಟು. Same way in the case of this one, that is negative deviation ಹೇಳಿದ್ರೆ 10 ml mix ಮಾಡಿದ್ರೆ 20 ml ಬರಬೇಕು. 20 ml ಅಂದ್ರೆ ಅದು ಯಾವ ಟೈಪ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್? ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್. ಬಟ್ ನಾನ್ ಐಡಿಯಲ್ ನೆಗೆಟಿವ್ ಆದ್ರೆ ಅಟ್ರಾಕ್ಷನ್ ಜೋರ್ ಇರುತ್ತೆ. ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಕಮ್ಮಿ, ವಾಲ್ಯೂಮ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ಕಮ್ಮಿ. ಸೊ ಮೇ ಬಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಎಕ್ಸ್ಪೆಕ್ಟಿಂಗ್ 20 ml, ಈಗ ನಮ್ಮ ವ್ಯಾಲ್ಯೂ ಬಂದದ್ದು 19.9 ml. Understood? So that is where the volume keeps changing with respect to positive deviation and negative deviation. You need to be, understanding this concept rather than just getting to know what are the differences. You mainly have to remember 2 points. That is, one is attraction and the other one will be repulsion. Very, very important to be noted down. So if you're writing the points, you can just say that before, the forces of attraction were actually stronger, but then after mixing, it has become weaker. That's why repulsion. So it is called positive deviation. The other side, negative deviation, before it used to be, weaker, but after mixing, the forces of attraction are stronger. That's why you call it negative deviation. Attraction, repulsion, are one word and NPD, but the delta H mix will be equal to positive. Here, delta V mix will be equal to positive. Here, delta H mix equal to negative. Delta V mix will be equal to negative. So this way, you can put up the differences between non-ideal solutions showing positive deviation and negative deviation. If I have to tell you with respect to the graph here, so again, positive deviation andre illi nodi, AB interactions will be lesser than AA ಮತ್ತೆ BB. Initially stronger ittu, but repel aguda karana, you say it is weaker than, AB interaction is weaker than under positive deviation. Delta H mix will be greater than 0 and the positive. Delta V mix also will be greater than 0. That is positive 1. Next, ಇದಕ್ಕೆ examples ನೋಡಿ. Acetone ಮತ್ತೆ ethanol, based on their bonding or based on their forces that is present. Actually, acetone alli it is dipole interaction. Dipole andre, you take an example, CH3, C double bond O, CH3. ಹೀಗೆ ಇದ್ರೆ ಇದೊಂದು ಕೀಟೋನ್ ಅಂತ ಹೇಳ್ತೇವೆ, ಅಥವಾ ಎಸಿಟೋನ್, ಇಟ್ ಇಸ್ ಪ್ರೊಪನೋನ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಹಿಯರ್ ಇಟ್ ಇಸ್ ಬೇಸಿಕಲಿ ಡೈಪೋಲ್. ಇಲ್ಲಿಂದ O minus, this is plus. So there is dipole interaction going on. But in the case of ethanol, it is hydrogen bonding. So C2H5OH ಅಂತ ಇದ್ರೆ ಇಲ್ಲಿ between C2H5OH there is strong hydrogen bonding. But mix ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ, there won't be stronger bonding when compared to their initial. Ethanol ಅಲ್ಲಿ stronger hydrogen bonding ಇತ್ತು, but after mixing there will be less interaction or less stronger forces of attraction will be there. That's why you call it positive deviation. They are undergoing repulsion. Initially ಅವ್ರದ್ದು strong ಇತ್ತು ಆ interaction. That's why they are not trying to mix with each other or form a type of bonding which can make it negative deviation. That is very important. You need to know that forces after mixing will be weaker than before mixing. That's all. Whereas in the case of negative deviation, you have a few examples like acetone and chloroform. Acetone and chloroform, there can be hydrogen bonding happening. Hydrogen bond is said to be stronger than dipole-dipole. After mixing, there will be hydrogen bonding. Andre stronger force aitu, attraction ಜಾಸ್ತಿ ಆಯ್ತು, vapor pressure ಹೋಗ್ತಾ ಇಲ್ಲ, vapor pressure ಕಮ್ಮಿ ಆಯ್ತು. That's why you call it negative deviation ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. I think you should just focus on the examples. Few of the examples you need to remember what type of force or what are the pairs that you have for positive deviation and negative deviation. I would prefer positive deviation, that is acetone and ethanol. For negative deviation, you can prefer acetone and chloroform, because in both you have acetone as common one. Like that also you can remember, or any way that you want. Okay. So this is very important, positive deviation and negative deviation. Okay. I hope this is clear. I hope this part is clear to you. So moving on to the clubbing of what exactly these non-ideal solutions and negative non-ideal solutions showing positive deviation and negative deviation. How exactly can we differentiate them? So positive deviation, non-ideal solution ali one positive deviation ittu, one negative deviation ittu. Once again, we will write down. So AB interaction will be weaker than, correct? Idu weak irtade, adike repulsion anta heludu. Will be weaker than AA and BB interaction. This will be a first point. Illi AB interaction will be greater, andre stronger attraction aitu than AA and BB, correct? This is first point. Next you went to delta H mix will be greater than 0. Andre it will be equal to positive value. Illi delta H mix will be equal to negative value. I want you all also to write it down once, scribble it up. Next you have delta V mix equal to positive, and this will be delta V mix equal to negative. Very, very important. Okay. Then you can also talk about a point, that is vapor pressure ittalla. Vapor pressure expected was from Raoult's law is said to be higher, alla? Graph high point ge shift aitu, whereas negative deviation alli kammi agittu vapor pressure. So you say that vapor pressure is high with respect to expected from Raoult's law. So ಸ್ವಲ್ಪ ಜಾಸ್ತಿನೇ ಇತ್ತು. Vapor pressure is said to be greater than expected from Raoult's law. Illi vapor pressure is less than expected from Raoult's law. Expected from Raoult's law. Okay. Vapor pressure is less than expected from Raoult's law. Here it will be higher than expected from Raoult's law. Put the same point, expected from Raoult's law. Raoult's law. Okay, so these are the differences you can put up. And one more reference I would like to tell, like, 1 minute. So one more point I would like to add. This is first point, this is second point, this is third point, and the fourth point. Next point, I will tell you something important, something which is, interconnected to a new topic that you need to know. That is, these are called, the positive deviation, solutions are called minimum boiling azeotropes. Minimum boiling azeotropes. The word looks like, you're hearing it for the first time. Actually, it's easy, I'll tell you. Minimum boiling azeotropes, and then you have maximum boiling. E negative deviation idgala, you call it maximum boiling azeotropes. Maximum boiling azeotropes. ಇಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಾಗಿರ್ಬೇಕಿದ್ದದ್ದು ಒಂದೇ ವಿಷಯ, what are azeotropes. Let's check onto that first, then we'll come to this. Okay. So first of all, what are azeotropes? Maybe imagine I have 95% ethanol, alcohol, and 5% water. So here I have in a beaker, ethanol ide, and 5% of water ide, imagine. I've added 95% ethanol and 5% water and add ಮಾಡಿದ್ದೇವೆ. So, ಈ particular composition ಅಲ್ಲಿ, ಅಂದ್ರೆ exactly 95% ಮತ್ತೆ 5% ವಾಟರ್ ಇದ್ರೆ, ಒಂದು ಬೀಕರ್ ಅಲ್ಲಿ ಮಿಕ್ಸ್ಚರ್ ಇದ್ರೆ, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಪೋಸಿಷನ್ ಅನ್ನು ನಾನು ಎಷ್ಟೇ ಬಾಯ್ಲ್ ಮಾಡಿದ್ರು, ಲೈಕ್ ಮೇ ಬಿ ಆಲ್ಕೋಹಾಲ್ ಇದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅರೌಂಡ್ 78.5 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಇಡ್ತೇನೆ. ಓಕೆ, Water is the boiling point, of course, you know, that is 100 degrees Celsius. ಈ ಎರಡನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ I'm expecting that, you know, somewhere I need to get a higher boiling point because 100 degrees Celsius plus 78 degrees Celsius, I need to get a large value, right? But ಈ ಒಂದು composition reach ಆದ್ರೆ, how much ever I try to boil, ಎಷ್ಟೇ heat ಮಾಡಿದ್ರು, ಇದ್ರ boiling point ಇದೆಯಲ್ಲ, it is not going far from 78.2 degrees Celsius. ಅವುಗಳ values ನೋಡಿ, 78.5, 100 degrees Celsius. ಅಷ್ಟು ಬರ್ಲೇ ಇಲ್ಲ. It has decreased, right? Correct? ಯಾವಾಗ ಇದು ಡಿಕ್ರೀಸ್ ಆದದ್ದು ಆ ಒಂದು ಕಾಂಪೋಸಿಷನ್ ಗೆ, ದಟ್ ಇಸ್ 95% ಎಥನಾಲ್ ಮತ್ತೆ 5% ವಾಟರ್ ಬಂದಾಗ ಮಾತ್ರ ಈ ಒಂದು ಕೇಸ್. ಸೊ ವಾಟ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಬೈ ದಟ್ ಇಸ್, ಈಗ ಎಥನಾಲ್ ಇದು ವೇಪರ್ಸ್ ಆಗ್ತಾ ಉಂಟು. ಓಕೆ, ಇಲ್ಲಿ ಎಥನಾಲ್ ಇದೆ, ಇಲ್ಲಿ ವಾಟರ್ ಇದೆ, ಮಿಕ್ಸ್ಚರ್ ಇದೆ. ಎಥನಾಲ್ ಇದು ವೇಪರ್ಸ್ ಇಲ್ಲಿ ಉಂಟು, ವಾಟರ್ ಇದು ವೇಪರ್ಸ್ ಇಲ್ಲಿ ಇದೆ. ಫುಲ್ ಸರ್ಕಲ್ ಮಾಡ್ತೇನೆ ವಾಟರಿಗೆ. ಓಕೆ, ವಾಟರ್ ಇದು ವೇಪರ್ಸ್ ಉಂಟು. When it reaches to such a stage wherein composition of your ethanol and water, composition andre ಎಷ್ಟು you know, amount of ethanol ಮತ್ತೆ water will be same in liquid phase. Andre composition of ethanol and water will be same in liquid phase and vapor phase. ಈಗ ಇಮ್ಯಾಜಿನ್ ಇಲ್ಲಿ 50 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಎಥನಾಲ್ ಮತ್ತೆ ವಾಟರ್ ಇದೆ, ಇಲ್ಲೂ ಹಾಗೇನೆ 50 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಎಥನಾಲ್ ಮತ್ತೆ ವಾಟರ್ ವೇಪರ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದ್ರೆ, ದೆನ್ ಯು ಕಾಲ್ ಇಟ್ ಎಸಿಯೋಟ್ರೋಪ್. ಎಸಿಯೋಟ್ರೋಪ್ ಅಂದ್ರೆ ನೀವು ಎಷ್ಟೇ ಬಾಯ್ಲ್ ಮಾಡಿ, ದ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇಸ್ ನಾಟ್ ಗೆಟಿಂಗ್ ಚೇಂಜ್ ಅಟ್ ಆಲ್. ಅದು ಒಂದು ಸ್ಟೇಜ್, ಇಟ್ಸ್ ಮೋರ್ ಲೈಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಎಷ್ಟೇ ವಾಟರ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದೆ ಅಥವಾ ಲಿಕ್ವಿಡ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದೆ, ಸೇಮ್ ಅಮೌಂಟ್ ವಿಲ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಗೇಷಿಯಸ್ ಫೇಸ್. ಆ ಒಂದು ಸ್ಟೇಜ್ ಅನ್ನು ಹೇಳಿದ್ರೆ ಯು ಸೇ ಮೋರ್ ಲೈಕ್ ಅನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ವೆರ್ ದೇರ್ ಇಸ್, you know, ಇಷ್ಟೇ ಬಾಯ್ಲ್ ಮಾಡಿದ್ರು there is no boiling point change at all. ಆ ಒಂದು ಸ್ಟೇಜ್ ಹೇಳುದು ಎಸಿಯೋಟ್ರೋಪಿಕ್ ಮಿಕ್ಸ್ಚರ್ ಅಂತ. ಓಕೆ, ಸೊ ಎಸಿಯೋಟ್ರೋಪ್ ಅಂದ್ರೆ ಯು ಕಾಲ್ ಇಟ್ ಅ ಬೈನರಿ ಸೊಲ್ಯೂಷನ್. ಬೈನರಿ ಅಂದ್ರೆ ಎರಡು ಸೊಲ್ಯೂಷನ್ ಅಥವಾ ಎರಡು ಕಾಂಪೊನೆಂಟ್ ಇದೆ. ಬೈನರಿ ಸೊಲ್ಯೂಷನ್ which boils at constant temperature. Of course, you heat how much ever you want, but the boiling point is still stuck in 78 degrees Celsius. Thermometer ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾನೆ ಇಲ್ಲ. Okay, so binary solutions which boils at constant temperature and also has equal composition, or it has same composition in liquid phase and vapor phase. Those you call it as azeotrope. ಈಗ ಇದು ಯಾವ ಟೈಪ್ ಆಫ್ ಎಸಿಯೋಟ್ರೋಪ್ ನೋಡಿ, ಅಲ್ಲಿ ನಮ್ಗೆ ಬೇಕಿದ್ದದ್ದು ಜಾಸ್ತಿ 78.5 ಮತ್ತೆ 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಮಾಡಿದ್ರೆ ಯು ನೀಡ್ ಟು ಗೆಟ್ ಅ ಲಾರ್ಜರ್ ವ್ಯಾಲ್ಯೂ, ಬಟ್ ದೆನ್ ವಿ ಗಾಟ್ ಓನ್ಲಿ ಹೌ ಮಚ್ ಹಿಯರ್ 78.2. ಸೊ ಕ್ಯಾನ್ ಐ ಕಾಲ್ ಇಟ್ ಅ ಮಿನಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಎಸಿಯೋಟ್ರೋಪ್? ಎಷ್ಟೇ ಹೀಟ್ ಮಾಡಿದ್ರು ಇಟ್ಸ್ ನಾಟ್ ಗೆಟಿಂಗ್ ಇನ್ಕ್ರೀಸ್, ದಟ್ಸ್ ವೈ ಯು ಕಾಲ್ ಇಟ್ ಮಿನಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಎಸಿಯೋಟ್ರೋಪ್. ಯಾವಾಗ ಆಗೋದು, ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಆದಾಗ ದೇ ಬಿಕಮ್ ಮಿನಿಮಮ್. ರಿಪಲ್ಷನ್ ಅಂದ್ರೆ ಯಾರು? ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್. ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಮಿನಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಎಸಿಯೋಟ್ರೋಪ್ ಆಲ್ವೇಸ್. Very, very important. So azeotrophs andre, it is a binary solution which will boil at constant temperature. I will just write it down. You please take it down, children. That is azeotrophs anta helidaga. I will put the definition here. Binary solutions. Binary solutions that boil at constant temperature. ಎಷ್ಟೇ ಬಾಯ್ಲ್ ಮಾಡಿದ್ರು ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ, ದಟ್ಸ್ ವೈ ಕಾಲ್ ಇಟ್ ಬಾಯ್ಲಿಂಗ್ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್, ಅಂಡ್ ಹ್ಯಾಸ್ ಸೇಮ್ composition in liquid and vapor phase. Liquid and vapor phase. Then you call it azeotrophs. Okay. Very, very important to be understood. So that is one thing. I hope you have copied it down. So your negative, your positive deviation solutions will be a minimum boiling azeotrope. Negative deviation solutions will be maximum boiling azeotrophs. So you will find more value than expected. You know, you can take an example of 68% nitric acid. Idu maximum boiling azeotropes example. 68% nitric acid plus 32% water. Baki will be water. This one you can take an example as maximum boiling azeotrope. Minimum boiling azeotrope iga kottadu, that is 95% ethanol and 5% water. This will be taken as a minimum boiling azeotrope. Maximum boiling azeotropes, not a minimum boiling azeotropes. You need to know the examples. Okay. So this was all about Raoult's law of volatile liquids. Then you went to the expression that is P total is equal to P1 naught X1 plus P2 naught X2. Then you also went to something called another expression in terms of X1 and the helbodu. Then you went to the type of solutions which can exactly obey the graph. Then you call it Raoult's law. So, which can obey Raoult's law are called ideal solutions. Andre, what are ideal solutions? The solutions that obey Raoult's law at entire range of concentration. Yaude concentration tegidru, it can obey Raoult's law. Then you call it ideal solution. AB interaction will be equal to AB and BB interaction. That is important. Delta H mix will be equal to 0. Delta V mix will be equal to 0. Examples ನೆನಪಿಟ್ಟುಕೋಬೇಕು. Then you have non-ideal solution showing positive deviation and negative deviation. Positive deviation ಅಂದ್ರೆ vapor pressure has increased. ಅದೊಂದು ನೆನಪಿಡ್ಬೇಕು. Why? Because repulsion takes place. Whereas in the case of negative deviation, it decreases. Why? Because there is attraction going on between two components after adding and before adding. Examples you need to remember. Then you went to the differences. I've put it up in the last slide here. Differences between the ideal and non-ideal. That one thing. Then a non-ideal solution showing positive deviation and negative deviation. You need to also remember this definition, that is azeotrope definition. Binary solutions that boils at constant temperature and has same composition in liquid and vapor phase. Those will be called azeotropes. Two types of azeotropes are possible. One is minimum boiling azeotrope and the other one is maximum boiling azeotrope. Example for minimum boiling is 95% ethanol plus 5% water. Maximum boiling azeotropes will be 68% nitric acid plus 32% water. So much you have to remember. Okay. So this was all about Raoult's law. That is, yes. So moving on to the, I can tell you that this is like the last part of the chapter. That is something called colligative property. Colligative property. Okay. Idu artha madidre, it is well and good to easily understand. Otherwise, again, you will have to, start getting confused and all. So this is better if you all understand right now itself. Colligative property. Easy there. There is nothing much. Yesterday, I think I've discussed about this, but then due to the internet stuff, I couldn't tell you properly. Anyway, coming to the colligative property. So this is the last part after azeotropes. So colligative property andre, like, we are going to talk about vapor pressure only. Mainly it is about vapor pressure. So imagine you have a liquid here. Imagine you have a liquid. So it's like a volatile liquid. Volatile liquid andre nimge gottide that it easily escape to vapors. Correct? Vapors irutte. Idu liquid alli, ishtu liquid alli ide. Idu vapors ge escape agutte. That's why you call it volatile liquid. Iga, ee volatile liquid alli ee vapors ideyalla. They don't stay as it is. I told you, they collide with each other. This will hit with each other. This will hit with each other. Correct? ಇದೆಲ್ಲ collide ಆದ್ರೆ ಏನಾಗ್ತದೆ, they will release what or they will exert what? Vapor pressure is what we call. So ಇವುಗಳಿಂದ ಒಂದು vapor pressure exert ಆಗುತ್ತೆ. Right? Now what you do? ಇದಕ್ಕೆ ಇದೇ ಒಂದು ಸಿಸ್ಟಮ್ ಇತ್ತು, ವೇಪರ್ ಪ್ರೆಷರ್ ಎಲ್ಲ ಜಾಸ್ತಿನೇ ಇತ್ತು, no problem at all, no disturbance was there. But right now, I'm going to add some disturbance here. That is, I'm going to add a non-volatile solute, children. ಇದರ ಒಳಗಡೆ, ಇದೇ solution ಒಳಗಡೆ, I'm going to add a non-volatile solute. Solute andre the one which is present in lesser quantity. But non-volatile means what? It is not escaping to which state? Vapor state. Non-volatile solute anna add ಮಾಡ್ತೀನಿ. Okay. So ಈಗ, don't you think that spaces are being covered by the non-volatile solute here? ಮುಂಚೆ ಆರಾಮ್ಸೆ they were escaping to vapors. ಯಾವುದು liquid vapor volatile ಆಗ್ತಿತ್ತು. But then right now I've added something which is a disturbance. Like, it is not able to, move. The liquid is not able to move and get converted to vapors. ಇಲ್ಲಿ ಒಂದು disturbance add ಆಗಿದೆ, ಒಂದು solid add ಆಗಿದೆ. Correct. Space ಎಲ್ಲ ಅವರಿಂದ ಆಕ್ಯುಪೈ ಆಗಿದೆ. ಪಾಪ ಈ volatile liquid ಗೆ vapor ಆಗ್ಲಿಕ್ಕೆ ಕಷ್ಟ ಆಗ್ತಿದೆ. Right? So what happens to vapor pressure? Initially vapors were high, I told you. So vapor pressure was there. Right now, just because you added non-volatile solute, what has happened to vapor pressure? Idu vapors ge escape ಆಗ್ತಿದೆಯಾ ಮುಂಚೆ ತರ? ಇಲ್ಲ, ಕಷ್ಟ ಆಗ್ತಿದೆ ಈಗ. So vapor pressure has, can I say that vapor pressure has decreased? Vapor pressure decreased ಹೇಳ್ಬೋದಾ? Why? Because ಆ liquid ಗೆ escape ಆಗ್ಲಿಕ್ಕೆ ಅಥವಾ in order to become vapors ಅಲ್ಲಿ ಅಷ್ಟು space ಇಲ್ಲ. So vapor pressure decreased ಅಂತ ಹೇಳ್ಬೋದು. This is one. Point number one to be noted. ನೆಕ್ಸ್ಟ್ ಇದೇ ನಾನು ಈಗ ಓಕೆ ನಾನು ಅದು ನಾನ್ ವಾಲಟೈಲ್ ಸೊಲ್ಯೂಟ್ ಹಾಕಿದ್ದೇನೆ ಬಟ್ ಸ್ಟಿಲ್ ಐ ವಾಂಟ್ ಟು ಸಿ ದ ವೇಪರ್ಸ್ ದರ್ ಐ ವಾಂಟ್ ವೇಪರ್ಸ್ ಬ್ಯಾಡ್ಲಿ ಅಂಡ್ ಐ ವಾಂಟ್ ಎಕ್ಸ್ಟ್ರಾ ವೇಪರ್ ಪ್ರೆಷರ್ ಸೊ ವಾಟ್ ಡು ಐ ಡೂ ಐ ಕ್ಯಾನ್ ಬಾಯ್ಲ್ ಇಟ್ ನೋ ಸೊ ಇದನ್ನು ಚೆನ್ನಾಗಿ ಹೀಟ್ ಮಾಡ್ತೇನೆ ಇಲ್ಲಿ ಇದೇ ಬೀಕರನ್ನು ಒಳ್ಳೆ ಹತ್ತಿಸಿ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಇಟ್ ಬಾಯ್ಲ್ ಮಾಡುವಾಗ ಆಟೋಮ್ಯಾಟಿಕಲಿ ದರ್ ವಿಲ್ ಬಿ ವೇಪರ್ಸ್ ಕರೆಕ್ಟ್ ಬಟ್ ಖಾಲಿ ವಾಲಟೈಲ್ ಲಿಕ್ವಿಡ್ ಇದ್ದಾಗ ಮೇ ಬಿ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ಖಾಲಿ ವಾಟರ್ initially but right now I have added some salt, imagine. So kali water when it was there, of course when I heat it there were vapors escaping but ಆ salt ಹಾಕಿದಾಗ ಏನಾಗಿದೆ ಈಗ spaces ಇಲ್ಲ water ಗೆ easily ಹೋಗ್ಲಿಕ್ಕೆ so kali water ಇದು boiling point ಎಷ್ಟು 100 degrees Celsius but right now when I've added salt can it easily escape? Can water escape easily? No. So what will happen to boiling point? Still more have to heat it no in order to escape it vapors just because I've added that salt or non-volatile solute. Now I have to still more increase the heat. So boiling point, vapor pressure ಕಮ್ಮಿ ಆದಾಗ vapors ಇಲ್ಲ ಕಮ್ಮಿ ಆದಾಗ ನಾನೇನ್ ಮಾಡ್ಬೇಕು boiling point. So I have to heat it. ಆಗ boiling point ಏನಾಗ್ತದೆ increase ಆಗ್ತದೆ than expected. Correct? ಇದೆಲ್ಲ ಯಾರ ಮೇಲೆ ನಾವು ದೂರ ಹಾಕ್ಬೇಕು ಖಾಲಿ ಆ ಸಾಲ್ಟ್ ಹಾಕಿದ ಕಾರಣ ಅಥವಾ ಖಾಲಿ ನಾನ್ ವಾಲಟೈಲ್ ಸೊಲ್ಯೂಟ್ ಹಾಕಿದ ಕಾರಣ ಇಷ್ಟೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಮ್ಗೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿಲ್ಲ ಇಟ್ ಡಿಕ್ರೀಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು ಇನ್ನೂ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕು ವೇಪರ್ಸ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿಗೆ ಸೊ ಕೆನ್ ಐ ಸೇ ದಟ್ ದ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ದಟ್ ಐವ್ ಅಬ್ಸರ್ವ್ಡ್ ಇಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹ್ಯಾಸ್ ಟು ಇನ್ಕ್ರೀಸ್ ದ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಕರೆಕ್ಟಾ boiling point increases. Next, boiling point with the freezing point, they are inversely proportional. So, of course, what happens to freezing point, children? Ide non-volatile solute hakida karana, freezing point will decrease, correct? Boiling point increase adre, freezing point, I'm sorry, I'll just write it here. Freezing point is decreasing. Correct? Bega freeze ಆಗ್ತಿಲ್ಲ, freezing point decreases. That is the idea, right? So this is one problem just because I added non-volatile solute. Idike examples alla kodtene nan matte. And these three are the observations that I actually see whenever I add a non-volatile solute mainly, right? So ಇವುಗಳೆಲ್ಲ ನಾನು ಯಾವ್ದೆಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಇಲ್ಲಿ ನೋಟ್ ಮಾಡಿದ್ದೇನೆ ದಟ್ ಇಸ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ಡ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು ಇದೆಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಇಲ್ಲಿ ಯಾರು ಬಂದ ಮೇಲೆ ನಾನು ನೋಟ್ ಡೌನ್ ಮಾಡಿದ್ದು ಆ ನಾನ್ ವಾಲಟೈಲ್ ಸೊಲ್ಯೂಟ್ ಹಾಕಿದ ಕಾರಣ ಇಷ್ಟೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಯ್ತು ಕರೆಕ್ಟಾ ಸೊ can I just put the blame on that non-volatile solute only? ನೀನ್ ಬಂದ ಕಾರಣ ಎಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು ಇಲ್ಲಿ that is vapor pressure decrease, boiling point increase, freezing point decrease, correct? ಇಷ್ಟೆಲ್ಲ ಆಯ್ತು ಖಾಲಿ ವಾಟರ್ ಇದ್ದಾಗ ಎಲ್ಲ ತೊಂದರೆ ಏನೇ ಇರ್ಲಿಲ್ಲ so any property that I'm going to put it on, the number of solute particles added, then I call it a colligative property. Any property. So, vapor pressure decrease is a property just because I added what? Non-volatile solute. So, what property do I call it as? Colligative property. Boiling point increase, just because I added salt. So, again, I call it what? Colligative property. So, colligative property is that property which depends on the number of solute particles added to a volatile solvent or to a solvent. That is called colligative property. Very, very important to be understood. Let me just put it up once again here. So colligative property andre they may ask you, okay, what is colligative property in the, you should be able to answer. Colligative property andre the property that depends on the number of solute particles, added to a solvent. That is called colligative property. Depends on the number of solute particles added is called colligative property. So in this chapter, that is solutions, you will be covering up 4 colligative properties. The first one is something called relative lowering of vapor pressure. Relative lowering of vapor pressure. Second one will be elevation elevation. I will tell you what is this, nothing to worry. Elevation of boiling point or elevation in boiling point. Elevation in boiling point. Then you have depression in freezing point. Depression in freezing point. And the last one that you have is osmotic pressure. Osmotic pressure. Okay. Osmotic pressure. So 4 colligative properties will be covering up in this chapter, which is the last part. So first of all, you just understood that vapor pressure decreases ಅಂತ ಗೊತ್ತಾಯ್ತು. ಆಗ ನಾನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತೆಗೆದಾಗ ಕರೆಕ್ಟ್ ಸಾಲ್ಟ್ ಹಾಕಿದ ಕಾರಣ ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು. ಅದಕ್ಕೆ ಹೇಳುದು ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್. ರಿಲೇಟಿವ್ ಅಂದ್ರೆ ಬಿಫೋರ್ ಅಂಡ್ ಆಫ್ಟರ್ ಯು ಕಂಪೇರ್ ಒನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಅನದರ್ ಒನ್. ಸೊ ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್, ದಟ್ ಇಸ್ ಫಸ್ಟ್ ಒನ್. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಯ್ತು, ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು. ಇನ್ಕ್ರೀಸ್ ಗೆ ಅನದರ್ ವರ್ಡ್ ಇಸ್ ಎಲಿವೇಶನ್ ಇನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. Freezing point ಏನಾಯ್ತು, decrease ಆಯ್ತು. That's why you call it depression in freezing point. And the last one is something called osmotic pressure, which I will tell you at the end. Okay, what about this? So let me tell you the scope of this part of this chapter is that you will in the form of board exam or in the form of competitive examinations. First of all, you need to know their formulas. What do they belong to? What is their expression? And numericals to be solved. So mainly this focuses on numericals. Okay. Solving part ali idu baratte colligative property. So properly if you understand and the basics of how this is bought, then it is easy. Athava nimge formulas ella gottadre it's going to be easy. Aramse nimge solve ಮಾಡಬಹುದು. So please focus on this. I hope you understood what is colligative property. Under that 4 colligative properties, once again it is RLVP shortcut, that is relative lowering of vapor pressure. Then you have elevation in boiling point. Then you have depression in freezing point. And the last one is osmotic pressure. Moving on to the first colligative property, that is relative lowering of vapor pressure. The first one is relative lowering of vapor pressure. The more and more number of times you keep telling this, the more it sticks on to your head, and you have to always keep scribbling. Then you know it's very easy for you to remember. Otherwise you go blank. So relative lowering of vapor pressure is the first colligative property. ಈಗ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಾಯ್ತು, ಡಿಕ್ರೀಸ್ ಆಯ್ತು. ಸೊ ಖಾಲಿ ವಾಟರ್ ಇದ್ದಾಗ ಜಾಸ್ತಿ ಇತ್ತು, ಕರೆಕ್ಟ್. ಖಾಲಿ ವಾಟರ್ ಅನ್ನು ಕೆನ್ ಐ ಪುಟ್ ಇಟ್ ಆಸ್ ಖಾಲಿ ವಾಟರ್ ವೇಪರ್ ಪ್ರೆಷರ್, ಐ ಕ್ಯಾನ್ ಪುಟ್ ಇಟ್ ಆಸ್ ನಾಟ್ ಮೀನ್ಸ್ ಅದು ಪ್ಯೂರ್ ಫಾರ್ಮ್. ನೆನ್ಪಿಡಿ ಕೇಳಿದ್ದೇನೆ, ಪ್ಯೂರ್ ಫಾರ್ಮ್ ಇದು ವೇಪರ್ ಪ್ರೆಷರ್, ಖಾಲಿ ವಾಟರ್ ಅಂತ ನೆನ್ಪಿಡಿ, ಕರೆಕ್ಟ್. ವೇಪರ್ ಪ್ರೆಷರ್ ಇತ್ತು, ಬಟ್ ಏನಾಯ್ತು, ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತಲ್ಲ. ಯಾಕೆ, ನಾನು ಸಾಲ್ಟ್ ಆಡ್ ಮಾಡಿದ ಕಾರಣ. ಸೊ ಐ ಜಸ್ಟ್ ಕಾಲ್ ಇಟ್ ಆಸ್ P1. ಸೊ ವೇಪರ್ ಪ್ರೆಷರ್ ಇನಿಷಿಯಲ್ ಇತ್ತು, ಬಟ್ ಈಗ ಡಿಕ್ರೀಸ್ ಗೆ ಮೈನಸ್ ಮಾಡಿ P1 ಅಂದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಯಾವ್ದ್ರದ್ದು, ಈಗ ಸೊಲ್ಯೂಷನ್. ಯಾಕೆ ಸೊಲ್ಯೂಷನ್ ಹೇಳುದು, ನಾನು ಸಾಲ್ಟ್ ಆಡ್ ಮಾಡಿದ ಮೇಲೆ ಏನಾಯ್ತು ಅದಕ್ಕೆ ಹೇಳುದು ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್. ಸೊ P1 ನಾಟ್ ಮೈನಸ್ P1. ರಿಲೇಟಿವ್ ಅಂದ್ರೆ ಐ ಆಮ್ ಕಂಪೇರಿಂಗ್ ಇಟ್ ವಿತ್ ದ ಪ್ರೀವಿಯಸ್, ಬಿಫೋರ್ ಅಂಡ್ ಆಫ್ಟರ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರು. ಇದು ಆಫ್ಟರ್ ಪಾರ್ಟ್. P1 ನಾಟ್ ಮೈನಸ್ P1 ಕಮ್ಮಿ ಆಯ್ತು, ಬಟ್ ಬಿಫೋರ್ ಹೇಗಿತ್ತು, ಖಾಲಿ P1 ಇತ್ತು. ದಟ್ಸ್ ವೈ ವಿ ಕಾಲ್ ಇಟ್ ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್. ಇದು ಫುಲ್ ಟರ್ಮ್ ಅನ್ನು relative lowering of vapor pressure ಹೇಳ್ತೇವೆ. That is P1 naught minus P1 divided by P1 naught compared to the initial, compared to the before. ಇದು ಖಾಲಿ ನೀರಿದ್ದು, ಇದು ಡಿಫರೆನ್ಸ್. ಯಾವಾಗ ಬಂದದ್ದು ಡಿಫರೆನ್ಸ್, ಆಫ್ಟರ್ ಆಡಿಂಗ್ solute to the particular solvent. So P1 naught minus P1 divided by P1 naught will be equal to, ಯಾರ ಮೇಲೆ ಬ್ಲೇಮ್ ಮಾಡಬೇಕು ನಾನು, ಸಾಲ್ಟ್ ಮೇಲಲ್ಲ ಅಥವಾ ಸೊಲ್ಯೂಟ್ ಮೇಲೆ ಬ್ಲೇಮ್ ಮಾಡುವ ಯಾವ ಪ್ರಾಪರ್ಟಿಗೂ ನಾವು ಹೇಳುದು colligative property ಅಂತ. So I have to blame it on solute 2. Just remember solute 2 ಅಂತ ಹೇಳ್ತೇವೆ. So its number will be 2. You can just blame it on solute, correct? But ಹೇಗೆ ನಾವು blame ಮಾಡ್ತೇವೆ, you talk about concentration of the solute. Concentration of the solute, maybe you can give it in terms of X2, because 7 concentration terms you studied previously. Molarity you studied, molality you studied, mole fraction. So let's just take an example of mole fraction, which is suitable for this type of, condition, wherein you call it mole fraction of the solute. Andre salt melene blame ಮಾಡಬೇಕು. That is relative lowering of vapor pressure. X2 ಅಂದ್ರೆ mole fraction of the solute. ನಾನು ವಾಟರ್ ಮೇಲೆ ಬ್ಲೇಮ್ ಮಾಡಿಕಿಲ್ಲ, ನಾನು ಸಾಲ್ಟ್ ಮೇಲೆ ಬ್ಲೇಮ್ ಮಾಡಬೇಕು. ಇನ್ನಿಂದಾಗಿ relative lowering of vapor pressure ಆದದ್ದು. That's how you say. So X2 ಅಂದ್ರೆ mole fraction. Mole fraction the formula ಏನು, that is N2 divided by N1 plus N2, correct? This is mole fraction, the formula. So you have it as P1 naught minus P1 divided by P1 naught is equal to N2 divided by N1 plus N2. So for a dilute solution ಅಂದ್ರೆ ಯಾವ ಮಾತ್ರ ಜಾಸ್ತಿ ಇರುತ್ತೆ? ವಾಟರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸಾಲ್ಟ್ ಕಮ್ಮಿ ಇರುತ್ತೆ. So what I'll do is from the denominator, I'll just ignore this N2. Okay. So N2 ಅಂದ್ರೆ solute particles. For a dilution, ಯಾವುದು ಜಾಸ್ತಿ ಇರುತ್ತೆ? ನೀರು ಜಾಸ್ತಿ ಇರುತ್ತೆ. That is N1. Number of moles of one component will be greater. So N2 by N1 ಅಂತ ಬರಿಬಹುದು. Correct. So this will be P1 naught minus P1 divided by P1 naught only. So N2 by N1 you can still write it in terms of masses. N2, yesterday I've told you that number of moles is equal to mass by molar mass. Correct? The formula. So mass now W ಅಂತ ಹಾಕ್ತೇವೆ. One second. So P1 naught minus P1 divided by P1 naught. N2 ಅಂದ್ರೆ mass by molar mass of 2. Correct? So you write it as mass is W. Molar mass ಯಾವಾಗಲೂ M, capital letter M. Mass small letter W. Molar mass capital letter M ಅಂತ ತಕೊಂಡು N1 ಇದೆ. So W1 by M1 ಹೀಗೆ ತೆಗಿಬಹುದು. If you still want to rearrange it, then you can write it as P1 naught minus P1 divided by P1 naught is equal to W2 M1 divided by M2 into W1. This can be used as a formulas for solving the problems, or you can also use P1 naught minus P1 is equal to X2. Or also you can use P1 naught minus P1 divided by P1 naught is equal to N2 by N1. Anything you can use depending on the, questions that is asked. Okay. Hope it is clear. Yes. Now, coming to the numerical part, how to use this in terms of, problems, I'll tell you. So P1 naught minus P1, please recite the formulas once again. That is P1 naught minus P1 divided by P1 naught is equal to X2. One more, you can write it in this form. That is P1 naught minus P1 divided by P1 naught is equal to N2 by N1 for a dilute solution. Or the last formula will be P1 naught minus P1 divided by P1 naught is equal to W2 M1 divided by M2 into W1. This way also you can tell. Let's just try solving a problem, children. Then it will be much more clear to you how exactly you take it. Yes. First of all, read the question. And, slowly I'll tell you and give how to crack and understand this question. Listen properly. The vapor pressure of, you have to understand the question as if you're doing this. Your beaker ide, ನಿಮ್ಮ ಎದುರುಗಡೆ vapor benzene ಹಾಕಿದ್ದೀನಿ, ಅದರ vapor pressure ಇಷ್ಟು. ಹಾಗೇನೆ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಇದನ್ನು crack ಮಾಡಬೇಕು. Okay. So first of all, vapor pressure of pure benzene ಇಲ್ಲಿದೆ. Pure benzene. Pure ಅಂತ ಹೇಳಿದಾಗ ನಾನು ಹೇಳಿದ್ದೇನೆ ಅದು ನಾಟ್ ಬರಬೇಕು. So P1 naught ಕೊಟ್ಟಿದ್ದಾರೆ. ಪ್ರೆಷರ್ ಅನ್ನು ನಾವು ಆಫ್ ಕೋರ್ಸ್ P1 naught ಪ್ಯೂರ್ ಬೆನ್ಝೀನ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಎಷ್ಟು ಅದರದ್ದು ವ್ಯಾಲ್ಯೂ 0.850 ಬಾರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಇಷ್ಟು ಲೈನ್ ಕ್ರ್ಯಾಕ್ ಆಯ್ತು. ಕರೆಕ್ಟ್. ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಪ್ಯೂರ್ ಬೆನ್ಝೀನ್ ಇಸ್ P1 naught is equal to 0.850 ಬಾರ್. ಡನ್. ಓಕೆ. ಸೊ ಒಂದು ಬೀಕರ್ ಅಲ್ಲಿ ಖಾಲಿ ಪ್ಯೂರ್ ಬೆನ್ಝೀನ್ ಇತ್ತು ಅಂತ ಅರ್ಥ. ಈಗ ನಾನ್ ವಾಲಟೈಲ್ non-electrolyte ಅಂದ್ರೆ they don't split into ions. ಹೌದು, ಹಾಗೇನೆ ಇರುತ್ತೆ when you add them. So a non-volatile, non-electrolyte which does not conduct electricity solid weighing 0.5 gram is added. So idra ಒಳಗಡೆ what did they add? 0.5 gram of solute they have added. So ಏನದು solute 2 ಅಲ್ಲ, solute 2 I've asked you to remember. solute 2 ಅದು ವರ್ಡೇ ಹಾಗೆ ಹೋಗ್ತದೆ. solute 2 ಅಂದ್ರೆ ಎಷ್ಟು ನಂಬರ್ 2. ಕರೆಕ್ಟ್. ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ಲಿ? ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಕರೆಕ್ಟ್. solute 2 ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮಾಸ್ ಅನ್ನು ಹೇಗೆ ನಾವು ಡಿನೋಟ್ ಮಾಡಿದ್ರೆ W, ಬಟ್ ಇದು 1 or 2. solute 2 ಅಂದ್ರೆ W2 ಹೀಗೆ. ಓಕೆ. ಸೊ W2 is equal to 0.5 gram ಅಂತ. ಓಕೆ. ಸೊ ಇದನ್ನು ನಾವು ಆಡ್ ಮಾಡಿದ್ದೇವೆ. ವೆನ್ ಆಡೆಡ್ ಟು 39 gram of benzene. ಬೆನ್ಝೀನ್ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲ, ಹಾಗಾದ್ರೆ ನಾವು ಯಾವುದೇ solute 2 ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ಬೆನ್ಝೀನ್ ವಿಲ್ ಬಿ 1 ಅಲ್ಲ. ಸೊ ಬೆನ್ಝೀನ್ ಇದು ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಎಷ್ಟು? 39.0 gram. Hope it is easy. We have reached till here. Next, molar mass. Molar mass, of course, now M, capital letter M. Molar mass is given for benzene, that is 78 gram per mole. Illi bracket alli kodidare. Benzene annu 1 tegdada, 2 tegdada. Non-volatile solute is 2. Benzene annu 1. So M1 is equal to 78 gram per mole. Sariya? ಇದೆಲ್ಲ ಆಡ್ ಮಾಡಿದ ಕಾರಣ 0.5 gram of solute ಆಡ್ ಮಾಡಿದ ಕಾರಣ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ದೆನ್ ನೋಡಿ ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತಲ್ಲ. ಇನಿಷಿಯಲ್ ಇದ್ದದ್ದು ಎಷ್ಟು? 0.85 ಬಾರ್. ಈಗ ಎಷ್ಟಾಯ್ತು? 0.845 ಬಾರ್ ಆಯ್ತು. ಸೊ ವೇಪರ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್. ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆದದ್ದು ಹೇಗೆ ಬರೆಯೋದು? P1 ಅಂತ ಬರೆಯೋದು ಅಕಾರ್ಡಿಂಗ್ ಟು ಫಾರ್ಮುಲಾ. ದಟ್ ಇಸ್ 0.845 ಬಾರ್. ಓಕೆ. Next, last part of the question is, what is the molar mass of the solid substance? Solid substance is solute. Molar mass of solute ಹೇಗೆ ಹಾಕೋದು? M2. Molar mass of the solute 2, M2. ಹಾಗೆ ತಗೊಳ್ಳಿ. Hope it is easy. So, of course, you know which formula is to be used. So, P1 naught minus P1 divided by P1 naught is equal to W2 M1 divided by M2 into W1. This is your formula. You want to find out what is M2 equal to. So, let's rearrange the equation. I'll take this up. This I'll get it down. This I'll take it up. Like more like cross multiplication. So, M2 will be equal to P1 naught. ಇದನ್ನು ಮೇಲೆ ತಕೊಂಡು ಹೋಗ್ತೇನೆ. W2 M1 divided by P1 naught minus P1 ಅದು bracket ಒಳಗೆ into W1. Correct? P1 naught value ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ ಎಷ್ಟು? 0.85 bar into W2 ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 0.5 gram into M1 ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 78 gram divided by P1 naught ಎಷ್ಟು? 0.85 bar minus P1 ಎಷ್ಟು? 0.845 bar into W1. W1 ಎಷ್ಟು? 39 gram. ಇಷ್ಟೆಲ್ಲ ಹಾಕಿ calculator ಅಲ್ಲಿ, you can put it up. I think you're going to get the answers. Second. Get the answer as. You can try it using calculator. I want you all to type and try it. Otherwise, it's going to be a big waste. You should know how to do it. I think you will get it as 170 gram per mole. If you check it, 170 will be the answer if you put it in the calculator. And also note that 170 unit ಏನು ಹಾಕೋದು children. ಇಲ್ಲಿ ನಾವು molar mass ಕಂಡಿಡ್ಬೋದು. M1 ಕೊಟ್ಟಿದ್ದಾರೆ already. M1 molar mass ನೋಡಿ, it is gram per mole ಅಲ್ಲ? Gram per mole. So this also has to be gram per mole. Very, very important. You have to put the unit or else you don't get the marks. 170 gram per mole is the answer. I hope it is clear. I hope it is clear. There's no doubt how to solve it. 2 solute ಅಂತ ಹೇಳಿದ್ರೆ 2 ಅಂತ ತೆಗಿಬೇಕು. ಮಾಸ್ ಅಂತ ಹೇಳಿದ್ರೆ W, small letter W. Molar mass ಹೇಳಿದ್ರೆ capital letter M ಅಂತ ತೆಗೆದ್ರೆ ಆಯ್ತು. ಅಷ್ಟೇ. Easy it is. Okay. Hope this is okay. Next we move on to the second colligative property. The second colligative property is the elevation. See here. First one is done. First one, relative lowering of vapor pressure. Formula you should know. P1 naught minus P1 divided by P1 naught is equal to W2 M1 divided by M2 into W1. Very, very important. Next we move on to elevation of boiling point. Boiling point increase ಆಗ್ತದೆ when you add non-volatile solute. When you add non-volatile solute here to a volatile solvent. Solute ಹಾಕಿದ್ದೀರಾ ಇಲ್ಲಿ. Solute ಹಾಕಿದಾಗ pressure increase, vapor pressure ಆಗ್ತಿಲ್ಲ ಇಲ್ಲಿ, vapors convert ಆಗ್ತಿಲ್ಲ. So what do you do? ನೀವು heat ಮಾಡ್ತೀರಿ. Heat ಮಾಡ್ದು ಕಮ್ಮಿ ಇರುತ್ತೆ. But then because of the solute, vapors escape ಆಗ್ತಿಲ್ಲ. So what happens to boiling point? Increase ಆಗುತ್ತೆ. That is what is called as elevation in boiling point. Correct? Increase in boiling point ಅಂದ್ರೆ elevation in boiling point ಅಷ್ಟೇ. So, again, whom do you blame it on? Just because of the salt, no? Or just because of the solute particles, you blame it on. And that's why it's called colligative property. So, you can say that Kali water is the boiling point 100. 1 second. Kali water boiling point 100 degrees Celsius. But ನೀವು solute ಹಾಕಿದ ಕಾರಣ ಈಗ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಮೇ ಬಿ 110 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಆಗತ್ತೆ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ. ಸೊ ಇದರಲ್ಲಿ ಯಾರು TB ನಾಟ್ ಯಾರು? ಪ್ಯೂರ್ ಅಲ್ಲ, ಪ್ಯೂರ್ ನೀರ್ ಇದ್ದದ್ದು ಇಲ್ಲಿ ಅಲ್ಲ. ಸೊ ಇಟ್ ಇಸ್ TB ನಾಟ್. TB ಅಂದ್ರೆ ಯಾರು? ಸೊಲ್ಯೂಟ್ ಹಾಕಿದಾಗ, ದಟ್ ಇಸ್ 110 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ TB. ಸೊ ಈಗ ಇಲ್ಲಿ ನಾವು ಡಿಫರೆನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಇಸ್ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ಮೈನಸ್ ಲೋವರ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ TB minus TB naught. Correct? This I can also put it as delta TB. Correct? Change in the boiling point, elevation in the boiling point. Initially, Kali neeradadu, that is 100 degrees Celsius, because just you added that non-volatile solute, right now the boiling point has increased. That's how you say that TB minus TB naught. And the difference find out ಮಾಡಬೇಕು. Higher value minus lower value. So delta TB, I can call it as elevation in boiling point, right? Elevation and the increase is type. So that I can put it as change in the boiling point. Delta TB will be equal to, ಯಾರ ಮೇಲೆ ನಾನು ಈಗ blame ಮಾಡಬೇಕು? Again, it's solute. So whenever you talk about boiling point, you use a concentration terms. ಅಲ್ಲಿ ನಾವು concentration terms use ಮಾಡಿದ್ದು, that is relative lowering of vapor pressure ಅಲ್ಲಿ X2 ಅಂತ use ಮಾಡಿದ್ವಿ, that is mole fraction. Here when it comes to boiling point, you use the concentration term, that is molality. Because again, molality is what? Number of moles of solute divided by mass of solvent in kg. Number of moles of solute. Again, you're blaming it on solute only. So this also can be used as a concentration term for boiling point. So this is the main expression that you need to know. That is delta TB is directly proportional to molality. Idu directly proportional ide, you just make it equal to by putting KB. KB andre constant. Apply a constant. This is also called boiling point elevation constant, or you can also call ebullioscopy constant. Ebullioscopy is a study wherein you talk about, higher temperature, that is boiling point. So this is KB into molality. This is a formula for boiling point, KB into molality. Or if you want to still more simplify, delta TB will be equal to KB into molality andre it is number of moles of solute. Number of moles of solute, correct? N2 divided by mass of solvent. Mass ege kodudu? Mass ige W. Mass of solvent. Solvent andre 1. In yaudu? kg. Correct? In kg. So ಇಲ್ಲಿ ನಾವು ಏನ್ ಮಾಡ್ತೇವೆ ಅಂದ್ರೆ ಇದನ್ನು ಗ್ರಾಮ್ ಇದ್ದದನ್ನು ಕೆಜಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಿದ್ರೆ what you do, you divide it by 1000. ಸರಿಯಾ? So when you still more rearrange, this becomes delta TB is equal to KB into 1000 into, correct, into N2 divided by W1. ಸರಿಯಾ? ಅದೇ KB into 1000 into, maybe I don't have number of moles. Number of moles will be written as mass by molar mass. Mass ಹೇಗೆ ಕೊಡುದು? W2 divided by molar mass into W1. This is the formula for delta TB. That is delta TB is equal to KB into 1000 into W2 divided by M2 into W1. Very, 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 very important formula for boiling point. I want you all to remember this. That is delta TB is equal to KB into M. And the other one is delta TB is equal to 1000 into W2 into KB divided by M2 into W1. This will be the formula for elevation in boiling point. You blame it on molality. There, mole fraction, you have blamed it on. Where in the case of RLBP. Okay, here you blame it on molality. So here there is a problem, you see. Boiling point of benzene is 353.23 Kelvin. So again, ಖಾಲಿ benzene ಅನ್ನು ತೆಗೆದಿದ್ದಾರೆ. ಖಾಲಿ benzene ಇದೆ. ಅದರ boiling point ಎಷ್ಟು? 353.23 Kelvin. So ಅದು ಪ್ಯೂರ್ ಅಲ್ಲ, ಪ್ಯೂರ್ ಅನ್ನು ನಾವು TB0 ಅಂತ ತೆಗಿತೇವೆ. That is 353.23 Kelvin. Next, when 1.8 gram of non-volatile solute, ಅದಕ್ಕೆ ನಾವು non-volatile solute ಹಾಕಿದ್ದೇವೆ. Solute 2, again it is W2 is equal to ಎಷ್ಟು gram? 1.8 gram. Next was dissolved in W1 ಎಷ್ಟು gram? 90 gram of benzene. The boiling point is raised to, andre, I'm sorry, this has to be 1 minute. This need not be delta TB. Allah. Why? Because they have given me the exact boiling point. So that's just TB0, right? That's just TB0. And of course, one more boiling point they've given after adding solute. How much is it? 354.11 Kelvin. So they have given me two temperatures. I need to find out the difference. That is delta. Anyway, calculate the molar mass of the solute. That is M2 is equal to how much ಅಂತ calculate ಮಾಡಬೇಕು. KB ಕೊಟ್ಟಿದ್ದಾರೆ. That is constant 2.53 Kelvin kilojoule per mole. Kelvin kg per mole. Okay. Ishtu values ಕೊಟ್ಟಿದ್ದಾರೆ. So let's just check out the formula once again. That is delta TB is equal to 1000 into KB into W2. Formula ಕಲ್ತಿರ್ಬೇಕು. Divided by M2 into W1. Right? Then what you do is you substitute 1000 into KB is to 2.53 into W2 is 1.8 gram divided by M2 is how much? We need to calculate. So keep it as it is. Into W1 is 90 gram. Delta TB. Delta TB is higher value minus lower value. Higher value is to 354.11 minus 353.23. Get what M2 is equal to. M2 is equal to ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ನೋಡಿ. And then let me know the answer. So that will be around. So 354.11 minus 353.23 ಮಾಡಿದ್ರೆ you get it as 0.88 Kelvin. That 0.88. So 1000 into 2.53 into 1.8 divided by 0.88 Kelvin into 90. You get the answer as around 57.5 gram per mole. It can be 57.27 or 58. It depends. But then 57.5 gram per mole would be the answer. Okay. So this is how you solve the problem for elevation on boiling point. And the third colligative property that you had is depression in freezing point. Depression and decrease in freezing point, correct? Depression in freezing point. Like, cold regions ali, andre, you talk about countries where there are roads ali alla, ice block agate, there will be ice regions, okay? Colder countries ali alla, illi ice alla biddirutte hige roads ali. So what happens? Movement of vehicles becomes difficult, correct? Vehicles ಗೆಲ್ಲ ಹೋಗ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ಈ ಐಸ್ ಮೇಲೆ. So what happens is ಈ countries ನವರು they sprinkle ಈ roads ಮೇಲೆ they put salt ಹಾಕ್ತಾರೆ, that is NaCl. Salt ಹಾಕಿದಾಗ ಅವರ freezing point decrease ಆಗುತ್ತೆ. ಅಂದ್ರೆ they don't freeze at the normal temperature, it's going to decrease because of which this ice is going to melt ಆಗ್ತದೆ. ಅಂದ್ರೆ freezing point ಅಷ್ಟು easily ಮುಟ್ಟುದಿಲ್ಲ. There is decrease in the freezing point. ಅರ್ಥ ಆಯ್ತಾ? So just in order to avoid this forming of these ice on the roads, what they do is they sprinkle salt in order to decrease their freezing point, because of which the ice starts melting, because of which transport becomes easy for them. Adondu example you can take, okay, for depression in freezing point. Again, depression in freezing point will be given as delta TF, difference in the freezing point before and after. Freezing point of water is actually 0 degrees Celsius, but ಈಗ decrease ಆಗಿದೆ. Okay, so it will be what? TF naught minus TF, correct? Decrease agide. When you add salt, freezing point decreases. That's why pure water minus after adding. So delta TF, again, you blame it on molality itself, because almost same it is, the concentration term. So delta TF will be equal to, illi ondu constant tarbeku, that is KF into molality. Or you can also write the last formula as delta TF is equal to 1000 into KF into, KF into W2 divided by M2 into W1. Same formula, nothing changed here. Just that instead of freezing boiling point, you just put it as freezing point. Okay, let's just solve a problem quickly based on this also. Again, 1 gram of non-electrolyte solute. Again, solute 2 ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಷ್ಟಾಗದ್ರೆ W2 is equal to 1 gram ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Next, is dissolved in 50 gram of benzene. ಹಾಗಾದ್ರೆ W1 ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಷ್ಟು? 50 gram. Correct? Lowered the freezing point of benzene. Already to temperature decrease agide anta ಕೊಟ್ಟಿದ್ದಾರೆ. So they did not give you like this temperature final initial ಹಾಗೇನ್ ಕೊಡ್ಲಿಲ್ಲ. They have seen that given you how much it has decreased. So how much decrease ಅಂದ್ರೆ delta change ಕೊಟ್ಟಿದ್ದಾರೆ. Change ಕೊಟ್ಟಿದ್ದಾರೆ, that is 0.4 Kelvin. Correct? The freezing point depression constant ಅನ್ನು ಹೇಗೆ ಹಾಕೋದು? KF is equal to 5.12 Kelvin kg per mole. And find the molar mass of the solute, that is M2 is equal to how much you have to calculate. So again, formula goes as delta TF is equal to 1000 into KF into W2 divided by M2 into W1. This is a formula, So 1000 into KF. KF value is 5.12 into W2. W2 is how much they have given? 1 gram divided by M2. We'll have to calculate delta TF and each other. So delta TF is how much? 0.4 Kelvin into W1. Please put it in your calculators and quickly calculate. So 0.4 into 50. Answer would come as around you can check it out once. Just a moment. Let me just give you the answer. You can check it in your calculator. There's nothing much. Please put up your answer. And once you get the answer, you will go through all the formulas. You get it as around 256 gram per mole as answer. If I'm not wrong, 256 gram per mole as answer. 256 gram per mole. Hope it is easy to solve. How to crack the question? I hope you understood the way of understanding the question. Yes. So till now we have discussed about the colligative properties, that is relative lowering of vapor pressure, elevation in boiling point is over, depression in freezing point is over. And the last one, what we have is osmotic pressure. Okay, let me just quickly discuss the formula. So osmotic pressure. Before understanding what is osmotic pressure, I want you all to understand the first word, that is osmosis. Osmosis. Okay. What do you mean by osmosis, children? Suppose you have raw mangoes ಅನ್ನೋ ನೀವು ಸಾಲ್ಟ್ ಅಲ್ಲಿ ಹಾಕಿಡ್ತೀರಾ. Raw mangoes ಚಂದ ಮಾವಿನ ಹಣ್ಣನ್ನು ನೀವು ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಹಾಕಿರ್ತೀರಾ. So after some time you see that mangoes exactly ಇದ್ದದ್ದು they shrink, correct? Because ಯಾವುದೇ ಲಿಕ್ವಿಡ್ ಇದ್ದದ್ದು ಅಥವಾ ಯಾವುದೇ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇತ್ತ ಮ್ಯಾಂಗೋದಲ್ಲಿ they have gone into the salt solution. ಅದಕ್ಕೆ ಇದು shrink ಆಗಿದೆ. So you say that concentration ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ ಈಗ ಉಪ್ಪಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ, ಕರೆಕ್ಟಾ? So you say that the movement of solvent molecules ಇಲ್ಲಿಂದ ಮ್ಯಾಂಗೋ ಇಂದ solvent molecules ಮೂವ್ ಆಗಿದೆ, ನೀರು ಮೂವ್ ಆಗಿದೆ from a lower concentration region, ಇಲ್ಲಿ low concentration ಇದ್ದದ್ದು, to a higher concentration region. Again, it is going to depend on the number of solute particles added. That's why you call it a colligative property. ನಿಮ್ಗೆ ಯಾರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ? That is salt particles ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. That's why you call it as osmosis. Mangoes ಇಂದ ನೀರು ಹೋಗಿ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಗೆ ಹೋಗ್ತಿದೆ. ದಟ್ಸ್ ವೈ ಮ್ಯಾಂಗೋ ಶ್ರಿಂಕ್. ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೊಸೆಸ್ ಇಸ್ ಕಾಲ್ಡ್ osmosis ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ವಾಟ್ ಇಸ್ osmosis? It is let me write it here. It is the movement of solvent molecules. Solvent ಅಂದ್ರೆ ನೀರು. Solvent molecules. Okay. From low concentration to a high concentration region. Okay. Through a semi-permeable membrane. Through a semi-permeable membrane. This is what you call it, osmosis. Okay. Because semi-permeable membrane andre you can talk about. So I was talking about an example, that is mangoes. You see, when it is the skin of mangoes, it is nothing but semi-permeable membrane. The lightest part of that particular skin will be called as a membrane, correct? So this process wherein movement of solvent molecules, please focus here, it is only movement of solvent molecules, only water is moving, nothing else. So movement of solvent molecules from low concentration to a higher concentration region will be called the osmosis. Okay. Now coming to our colligative property, what is osmotic pressure? Osmotic pressure will be the pressure applied. You talk about this. Maybe I'll give you an example here. Each side alli you have Na. I have two compartments, okay? Idu ee naduvalli ondu line ide alla, that is nothing but semi permeable membrane. This is semi permeable membrane, imagine. Okay, idondu thin layer ide naduvalli. So this is NaCl solution. Aita? And here you have pure water, imagine. Illi pure water ide. Pure water. Aita? Full fresh water ide. Now what happens is, osmosis andre, of course, a neeru molecules nillade illa, they move from low concentration. Elli low concentration illi alla. Kali neer iddaga you call it low concentration. Elli solute particles jastide, you call it high concentration. So from here, the solvent molecules, that is water molecules, will move from low concentration region to high concentration. So your movement is from left hand side to right hand side. That is called osmosis. ನಿಮ್ಗೆ ಡೆಫಿನೇಷನ್ ಅರ್ಥ ಆದ ಪ್ರಕಾರ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ಮೋಸಿಸ್. ನೀರು ಒಂದು ಲೋ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಂದ ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ರೀಜನ್ ಗೆ ಹೋಗ್ತಾ ಇದೆ, ಉಪ್ಪಿನ ನೀರು ಸೈಡ್ ಗೆ ಹೋಗ್ತಾ ಇದೆ. ದಟ್ ಇಸ್ ಆಸ್ಮೋಸಿಸ್ ಥ್ರೂ ಅ ಸೆಮಿ ಪರ್ಮಿಯಬಲ್ ಮೆಂಬ್ರೇನ್, ಆಫ್ ಕೋರ್ಸ್. ಈಗ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಅಂದ್ರೆ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅಪ್ಲೈ ಸಮ್ ಪ್ರೆಷರ್ ವೇರ್ ಯು ಸಿ ಪ್ರಾಪರ್ಲಿ ಇಲ್ಲಿ on the top of this NaCl solution, I am going to apply some pressure. Osmotic pressure ಅನ್ನು ಡಿನೋಟ್ ಮಾಡುದು ಪೈ ಸಿಂಬಲ್ ಇಂದ. ಇದು ಈ ಪೈ. It's of course used in mathematics 3.14, but do not confuse. Here also for colligative property, we are going to use it as pi only. Okay. So, ee pi hakida karana, you see that there is a moment. Yes. So, here you have pure water. So, from here when you apply pressure, okay, ಈಗ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಮೂವ್ ಆಗ್ತಿತ್ತು ಇಲ್ಲಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇಂದ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ಗೆ ಉಪ್ಪಿನ ನೀರು ಸೈಡ್ಗೆ ಮೂವ್ ಆಗ್ತಿತ್ತು. ಈಗ ಮೇಲಿಂದ ಅಲ್ಲಿ ಪ್ರೆಷರ್ ಹಾಕಿದ್ದೀರಾ. ಸೊ ಈ ಯಾರು ಇಲ್ಲಿಂದ ಇನ್ಕಮಿಂಗ್ ದಟ್ ಇಸ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಲ್ಲಿಂದ ಬರ್ತಿದೆ, ಕರೆಕ್ಟ್? ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇಂದ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ಗೆ ಬರ್ತಿದೆ. ನೀವು ಪ್ರೆಷರ್ ಹಾಕಿದ ಕಾರಣ ಆಟೋಮ್ಯಾಟಿಕಲಿ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ದೀಸ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಗೋ ಬ್ಯಾಕ್, ರೈಟ್? ನೀವು ಇಲ್ಲಿಂದ ಪ್ರೆಷರ್ ಹಾಕ್ತಿದ್ದೀರಾ, ಸೊ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಗೋ ಬ್ಯಾಕ್. ಆಗ ಆಸ್ಮೋಸಿಸ್ ಆಗ್ತದ? ರಿವರ್ಸ್ ಹೊಡಿತಾ ಉಂಟು. ಸೊ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ no osmosis being happening. The movement of solvent molecules is not happening from left hand side to right hand side, right? Or low concentration to high concentration. Why? Because you just apply pressure. So what do we call it? An osmotic pressure. The pressure applied onto the solution. Idu kali solvent. Idu kali solvent. Correct? Idu kali solvent. Idu full solution. So the pressure applied towards a solution. Okay? In order to stop osmosis. Osmosis ಆಗ್ತಿಲ್ಲ ಈಗ because you apply pressure. ಇದು ರಿವರ್ಸ್ ಹೋಗ್ತಾ ಉಂಟು. So in order to stop osmosis, that will be called osmotic pressure. Okay, I hope it is clear. So idu osmotic pressure will be given as pi. I told you pi is directly proportional to concentration, children. ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದೆಯಾ ಅಷ್ಟರ ಮೇಲೆನೆ ನೀವು ಪ್ರೆಷರ್ ಹಾಕ್ಲಿಕ್ಕೆ ಆಗೋದು, ಕರೆಕ್ಟಾ? ಈ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬರೋದಾದ್ರೆ ಮಾತ್ರ ನೀವು ಪ್ರೆಷರ್ ಹಾಕ್ಲಿಕ್ಕೆ ಆಗೋದು, because of which osmosis stops. So it is directly proportional to concentration. Remember this. And pi is, we have to remove the proportionality symbol. That's why you call it pi is equal to CRT, where R stands for a constant, T also stands for constant because we are doing it at constant temperature. And this is R, that is universal gas constant. So that is the constants used, wherein pi is made equal to concentration. ಈಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಯಾವ ಟರ್ಮ್ ಅಲ್ಲಿ ತೆಗಿಬಹುದು? ನಮ್ಮದು ಮೊಲಾಲಿಟಿ ಆಯ್ತು, ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಯ್ತು. ಈಗ ಆಸ್ಮೋಸಿಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಐ ವಾಸ್ ಡೀಲಿಂಗ್ ವಿತ್ ಲಿಕ್ವಿಡ್ಸ್ ಅಲ್ಲ, ಒಂದು ಲಿಕ್ವಿಡ್ ಈಚೆಂದ ಇನ್ನೊಂದು ಲಿಕ್ವಿಡ್ ಗೆ ಮೂವ್ ಆಗ್ತಿದೆ. ಐ ವಾಸ್ ಡೀಲಿಂಗ್ ವಿತ್ ಲಿಕ್ವಿಡ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಿಮ್ಗೆ ಬೆಟರ್? 7 ಇತ್ತು ಮೊಲಾರಿಟಿ. ಲಿಕ್ವಿಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಒಂದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ ಇಸ್ ಗುಡ್? ದಟ್ ಇಸ್ ಮೊಲಾರಿಟಿ, ರೈಟ್? ಮೊಲಾರಿಟಿ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಹೇಳುದು ನಾವು? ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್, I'll put it here. Number of moles of solute, correct? Divided by volume of solution in liter. Volume ಮೇಲೆ depend ಆಗುತ್ತೆ. So, best for liquids will be molarity. So, you say that pi is equal to CRT. C is nothing but molarity into R into T. Correct? Concentration and molarity into ತೆಗೆದಿದ್ದೇನೆ. Molarity formula ನಿಮಗೆ ಗೊತ್ತು. Number of moles of solute 2 divided by volume of solution in liter. Volume of solution liter into R into T. ಇದು ಬಾಕಿ ಹಾಗೇನೆ ಇದೆ. Correct? Or pi is equal to N2 ಅಂದ್ರೆ ಏನು? Number of moles of solute. Number of moles of solute will be W2 by M2 into V in liter into R into T. So last formula will be given as pi is equal to W2 RT divided by M2 into V. So this will be the formula for osmotic pressure. Remember that volume of a solution is in liter. Whenever volume of a solution is in liter, R value changes to 0.082. ನೆನ್ಪಿಡ್ಬೇಕು. ಅಥವಾ you just take it as 8.314, right? Joule per mole per Kelvin. But then whenever volume of a solution is in liter, R value changes to 0.082. Sometimes they give it in the question, but you also need to remember. Okay? So please note down the formula. Pi is equal to W2RT divided by M2 into V. And also this formula, pi is equal to CRT. Very, very important for competitive part. Pi is equal to CRT. This is also important. Yes.